start streaming.
Mm.
And
You are
So this isn't live?
oh yeah, we're live on 3 Space already.
Oh yeah.
Now we are live on Try Thinking 2. Having a
Oh, you're going live on track.
chat with Tommy. Yeah. So be on your best behaviour.
always on our best behaviour.
Oh, Tommy sent me a message. Hey, got a link again? What? Okay. I'm sure I've just sent him one though.
Was it a DM?
I'll send him a message straight through. Copy that. And then I can send him. Oh, it's already gone through. You should already have that. You're all going to be good, right? And no talking to Tommy. He gets upset.
No, okay. I don't talk to Tommy. Unless Tommy talks to me.
Yeah. Don't be intimidating either, Essie. No standing in the corner looking intimidating.
Okay, I won't stand. I won't say nothing. Hey, whatever happened to that guy that I brought in one day? Did he ever come back? Remember that guy? I forgot his name.
Oh, look, Squawkins is here as well. He's in the live chat. He must have seen me go live. Yeah. Yes, Sean. Here's Tommy's typing now, see? I don't know whether it was a debate. That's not what Tommy said. Tommy just said he wanted to ask me lots of questions.
Oh, is that what he said?
I think so.
So he wants you to be asked and answer lots of questions and nothing.
Isn't that what it said in that thing? There will be 2 conditions, though. It will be you and me, nobody else. You got to answer just as many questions from me as I have to you. Sounds only fair, right? That there is 2 conditions. So just me and him, and that he can. You got to answer just as many questions from me as I have to you. So I have to answer his questions as many as he has for me.
Does that mean we need a question score counter?
I don't know if that was a 1-for-1. It doesn't actually say that. It says
that would be the best thing, wouldn't it?
Go answer just as many questions from me as I have to you. He gets to ask questions. That's it. I think, as far as I know.
Yeah, you'd best go 1-on-1, wouldn't it? Ask one question, answer one question.
I think he's saying you owe him some questions.
Oh, wait a minute.
From last time.
He must have left, I think. He says, I'm there, but no live stream. What's he going on about?
Has he got the right roles?
Where is he?
Not
Why can't he post?
Morty Master's here.
Where's Tommy? Why can't he see the live stream?
Is he not in the landing? Tommy, yeah, there you go.
Is he? He must have left then.
He's got a live stream now.
Okay.
Have you just rolled him up?
Yep. What's up, Tommy?
He must have left when he was in there last time.
Live chat been
There you go.
Until now.
Okay, welcome,
Tommy.
Tommy.
A little bit quiet.
I'm quiet. Last time I was loud.
Mic check. That sounds good for me.
All right, cool.
I'm going to turn up that gain just a little bit. So, Back again, and this time, as Bev was agreeing on, this will be a one-on-one. So everybody else, just keep the hell out of here.
Yeah, I'm gonna server mute Morty Master, and then I'll mute myself. Enjoy.
Thanks.
Good afternoon. How are you? So
You are loud, low now, so I'm going to turn you up here a bit.
I'm low, am I? Do you want me to get the mic a bit closer?
I can do that on the OBS here.
Okay, okay.
I think. Let's turn you up a bit here. Let's say 6. Yeah. There we go.
Okay. Right. Well, in the thing that you said, you put there was 2 conditions, just me and you, obviously. I mean, that's going to be. But the other one says you got to answer just as many questions from me as I have to you.
The other way around, yeah.
But
fair.
Does that mean you just ask questions? And
no,
I have to answer as many as you have.
This will not be a one-way interrogation. It's going to be a 2-way conversation. That's it.
Okay. But it's not just you asking questions then, no?
No, that's exactly the opposite. It's not you only asking questions. It'll be both of us.
Yeah.
Yeah. That's
okay, so at the beginning, can we start off with the definitions thing, right? That when we're using words at the beginning, we can deal away with this, and then we can carry on with the conversation, right? Once we know the words that we're using, and then we don't get into a semantical thing later on. Were you saying it's semantics when it's a word that's defined to mean something? Can we establish
First of all, we'll
first?
start off with the last the thing we had, because you called me a liar, and I don't like that.
When did I call you a liar?
When you said I wasn't a surveyor.
I said I don't think you're a surveyor.
You said I wasn't a surveyor, and I was asking if you said I was
Are you a surveyor?
I was a surveyor.
Are you a surveyor?
I was a surveyor, and you said I wasn't. I asked you if you said I wasn't, and you said yes, and I said you're lying. And you said I was lying.
Okay.
So just want to get that off.
Okay. You say you've done some surveying. Yeah, that's understandable.
I said I worked as a surveyor for 5 years, and you said I didn't.
For 5 years?
Yeah. We said that last time.
Mm-hmm.
And you said I was lying. I don't like that.
Okay. So you'll be well qualified when we start talking about surveying, because that's what we'll do. That's a lot of what we do, is talk about practical things, and surveying is just the practical form of geometry, right?
As I also said, I wasn't schooled in it. I learned it while I was there.
Okay.
So I'm not an expert in surveying. I never said I was an expert.
You've got practical experience, though, right?
Yeah.
Okay. Now, can we go over some definitions of what you think and what you don't think, whether we can use the words that we're going to be using?
To be honest, I really don't see why this is, as I said last time, why this is all you do. You just debate semantics and definitions.
This isn't a debate about semantics. This is just establishing definitions at the beginning.
As both you and I know, surveying works. That's all we need to know.
Surveying works because it works through the principles of Euclidean geometry, right? And those words are very well defined in mathematics. That's what I want to just get with you at the beginning, the understanding of where we get our definitions from. So we don't just end up making them up.
You're usually saying that level equals flat, but it isn't. That's the only thing.
You've never heard me say that, because I've never said that.
Well, let's disagree about that one.
Go on, give us a citation of where I said that then.
On some YouTube videos, I don't have a recording of it.
I've never said that. I don't use that word. It's not one of the words I use. Although I can get you in the live chat if you want. I can get you because
I know that level means coverage of the earth, so it's no problem.
Pardon?
I know that the definition of level is following the curvature of the earth, so it's no problem.
Oh well, if it's going to be that, if you got definitions for that? Because I mean,
Merriam-Webster dictionary.
go on then, give us it, please. Like, don't
Sure.
don't just say that. If you're gonna do that, please give us the definitions that you are citing. Because you say you don't want to be doing that. Is that what you're using? Is like just that level? Because I'm don't ever need to use the word level. Right? I can just use horizontal and perpendicular, vertical. Right? As you can as well. You can use the same words. There's no need for you to imagine level to be anything that it isn't. You can just not use the word if you want. If that's all right.
Just paste it in the live chat. Paste the link in the live chat there.
Okay. Well, see this. I've got a definition here from a really old dictionary. You see that flat?
Yeah, but
What does that say for flat? The adjective.
yes, that's flat. But it
Flat.
also
It
means
says
that it follows the curve.
horizontally level. That's
Yeah.
for flat.
But that's not all of it. It's more.
It's just an old meaning of a word, right?
Yeah.
That's what I'm getting.
Level
So
also
I'm
means from the curve of
I'm guessing that you're not going to like that meaning of the word flat, are you?
I never denied it.
What, that flat is horizontally level? You'd be all right with that, would you?
Yeah.
As a
local
meaning,
point, I
because we
suppose,
can
last time,
go
yeah.
along with that if you want.
No, but you
like
talk
I
about
say,
definitions, and I just
I
said
don't
that level
need
means curvature.
to use that word. Well, there's no curvature in a horizontally level flat, is there? There's definitely no curvature to flat.
I'll just I'm gonna copy paste one here from that what I just conforming to the curvature of the liquid parts of the Earth's surface.
Okay, right. Well, did you see the little bit a bit earlier? Do you want me to go over that? I'll
but it doesn't
find
contradict it. It just adds
What
to
do
it.
you mean it
It's
doesn't
more.
contradict it? Well, like I say, if you want to do this, we can. But
When I
is
just
is
got
this
there, I
what-
said it was a bit.
Go
I
on.
said it was a bit low. What did I do then? I turned up your audio level. So level means a whole lot.
Yeah, it means different things. Yeah. Like a computer level. But when, particularly in the bit that we are talking about, it only means one thing, and that's a horizontal plane.
It doesn't mean only one thing.
Right, here. Look, see this. Now, this is the Merriam-Webster dictionary that you are using, but you've completely skipped all of these to
No,
find one
I don't deny
particular
that.
one. Right?
I just added to it. I didn't deny
Okay.
it. I just added to it.
But
There's more.
Can you see number 3 on that one?
Yeah,
Okay.
equilibrium keeps on popping up here.
Yeah. It says horizontal
Especially
condition.
equilibrium of a fluid marked by horizontal surface on even altitude. Yeah?
And it says water seeks its own level.
Yeah?
Right, so what the
Level?
bit that you said, conforming to the liquid parts, right? Well, according to that, in the very same dictionary, it's a horizontal condition. So that's what level conforms to. It conforms to the horizontal condition, because that's what water does, even in the dictionary that you cited.
Yeah, at local point, yeah.
Yeah, that's why we
at one
say,
local point.
when we say an equilibrium of a fluid marked by a horizontal surface of even altitude, right? Altitude takes it above, doesn't it? It takes it off the surface.
No, nobody denies that.
Yeah, it does. Even altitude means it's away from the surface, doesn't it? Elevation is on the surface, and that's when you have a height above mean sea level of elevation.
Yeah, but again, as I
And
said,
anything
nobody's denying
above that is classed as altitude, isn't it?
Yeah.
Right, so when it
Elevation.
says
Yeah.
an equilibrium of a fluid marked by a horizontal surface of even altitude, it means that the surface of the water in the tubes are both at an equilibrium away from the surface, because they are. And that being away from the surface means it doesn't matter what the surface does. Once you establish in a horizontal off the surface, right, it's not
Locally.
what's underneath it doesn't matter, right?
Yeah, but that's locally, and nobody knows that.
Okay.
So again.
Okay, so you are having horizontal as being a water surface, a water level.
Again, nobody denies this.
Okay, right. Well, that's like we can go forward now. Now we know a water level establishes a horizontal surface of even altitude. We can just move forward. That's good.
Yeah,
it's a good starting point for us. So that was one of the words I wanted to get away with, right? Horizontal and altitude, because altitude's above the surface, and
elevation. As I said last time, elevation.
Elevation is the surface, right? That's the mountain or the land has an elevation. Anything above that is classed as an altitude, isn't it? Off the surface, away from the surface. That's the difference between altitude and elevation.
Yeah.
Okay. Now,
probably, I'm not that in English dictionary, so I'll agree.
Okay.
Sure.
Now, the other one would be perpendicular, because that's one thing that I use quite a lot within the geometric terms. Right now, it sort of comes with a proof that straight lines are straight, because there is only straight lines.
Perpendicular is. We don't need to debate that to discuss that.
I know, but there's a lot of people listening in, or maybe people listening in the future, whatever, that don't know this, right?
We don't need to sit there for an hour to talk about something we agree on.
Well, perpendicular being two straight lines has to be two straight lines. It's a proof that the line is straight, because if there was any curvature to it, it wouldn't be perpendicular. Right, so that differentiates straight lines from curved lines. The very word perpendicular.
How long do they have to be a line? Does it if it's 1 millimeter and you have 1 millimeter perpendicular to that? That's two lines. You can curve afterwards.
Yep. Well, there's another one. In geometry, you can extend a straight line indefinitely.
Yeah.
Can't you? For the very fact that you have a straight line to start with, you can then extend it indefinitely.
Yeah.
Okay, brilliant. That's it. I think that's me sorted. So as long as we've got those words sorted, I don't think we need to have any semantical conversations. So where did you want to go with this, and where do you want to start at?
Again, I really don't see why we should discuss and debate so much about the mechanics of surveying, because, as I said, we agree on all of that. Surveying works.
Okay, well, in reality then, do you want to talk about our straight line test?
How about that? Yeah. Well, again, I want to bring back something from last time.
Okay.
When I showed you, I'm going to screen share in a few seconds. I'm going to fire up SketchUp first. You talked about when I had the 3D models here that all of this was wrong. It should match reality and all of that stuff.
I didn't talk about your models.
You were one of them. You screamed and shouted.
I think I did say, are they Ruhifs? Because they did look very familiar. I think I've seen them on Ranties. Does Ruhif perhaps use the same program?
I'm going to... Where did OBS go? Here. And yeah, I have too many windows open now. There we are. So I'm on the screen share.
Okay.
That one. You said last time. All of the guys said last time. I just adjusted those to the.
Oh, you put the extra ones in.
Yeah, but again, it's not easy to say actually where these are originating inside here. So that's why those goes all over the place. But I said this was an example, and you yelled at me because it wasn't reality.
No.
You
I
also
didn't
said,
yell at you.
Wait a minute now, please. I'm just going to continue. The blue, red, and yellow lines here wasn't straight. And I said it's because the camera. So when I move the camera, those lines move. That's why it's not straight. It's as simple as that. And you shouted at me because those wasn't straight.
Shout at you, dude.
This is bullshit, man.
You're
also,
I think you're imagining things.
I said something wrong. I said 10 kilometers. This is millimeters. I said wrong. This is not 10 kilometers. It's 1,000 meters or some 100 meters. Also, you screamed at me because this wasn't reality. Yeah, I said several times it wasn't an example. So, all of those drawings of yours, is that water test supposed to be just 1 meter wide?
Pardon?
All of those drawings you have of the water test, water level test.
Dude, which
is
drawings?
That test supposed to be 1 meter wide?
Which drawings are you talking about? Do you have them?
Those you have in your whiteboard.
Sorry?
The drawings you have on your whiteboard.
When I do drawings on the whiteboard. Are you asking me how big's my whiteboard?
No, I'm just asking you if
a whiteboard
your water
size
level test
contest.
is supposed
How
to be
big's
1
your
meter
whiteboard?
wide.
I'll tell you how big mine is. Okay.
So, if I can make examples, why can you draw examples? If this wasn't okay for you to be an example, as I said several times, you screamed at me because it. Why can you draw examples on your whiteboard? Isn't that just the same?
It's 90 centimeters wide. You don't want to know how long it is, do you? Because the camera won't get top to bottom.
So your water level test won't be bigger than 90 centimeters wide then?
What? Sorry?
Your water level test won't be wider than 90 centimeters wide.
Why not? Have you not seen the water levels that we've got?
I'm just asking because since my 3D model wasn't good as example, I guess your drawing has to be exact.
No, you said they were the Stadia hairlines, and they weren't.
I said it was an example. I said it was an example.
An example of Stadia hairlines. Well, it was a really bad example. Like I said,
I'll
still stick with behind what I said. It's not accurate, right? And it's not even close to being accurate, is it? And you did just add some new ones, didn't you? You added some new ones, and is that where you imagine that the bottom one goes to?
Again, I'm not sure where they originate inside that level, so it's impossible.
I did a meme. Well, not a meme.
But again, if it's supposed to be that way, why can't you use mine as an example when I said it was?
There you go.
I don't see the difference there.
I was inspired by what you did.
Yeah, sure.
I put questions together. So do you see that? Like, because I was looking at that and I thought I'll do a drawing to try and see what we do. And like I put it 2 meters above mean sea level with the. Are
you sharing
level.
something now? I don't see it.
No, it's just in the live chat. We use the main in the live chat.
Oh, yeah, it was in the other screen there.
Yeah.
There, yeah.
Yeah, so that, and inspired by what I saw with your picture, and I asked you how far away it would be. I did this, and see that there's a bit of geometry in it, if you understand it, and so you get given the equal angles in that thing, which means the 2 lines are parallel, and if you know those equal angles, then you should be able to tell at what distance it would disappear into the floor, right?
Yeah, sure.
Do you know what distance that should be? I mean, that it does say what distance, question mark. What do you... Because I think you just did it. You modelled it and actually drew it for yourself, didn't you?
Yeah, but again...
Where did you put them?
As I just tried to say, please stop interrupting me. Don't let me rerun of the last time, please. I don't know where inside that level those lines originate. So if they are just 5 millimeters behind the glass, they go straight up and down. If they're at the eyepiece, they go just about where I had them. So I don't know where it originates. It's impossible to know.
Well, they are used. The Stadia hairs are used for distance measurement.
Yeah, I know.
Aren't they?
But
so I mean, like it's getting a distance. It should be quite easy because that's what the device is there for. Not in a model. What?
Not in a model.
What do you mean not in a model? I've put it in there, given equal angles. You've got parallel planes.
Yeah.
You've got the auto level has got a horizontal plane, and the floor is because given equal angles.
I mean, I can, as you showed me last time with your son and that pole.
Yep.
I'm going to open that again. File, open. What I could do.
I don't want to, it's something for you to take away. It's not a challenge for you to do right now.
I know.
Right? I don't expect you to do that.
I just
thought you'd already modelled it on your thing because you'd actually put those extra stadia hairs in, and they do cross the floor. I was just wondering whether you'd actually put a distance to that.
Yeah, what I can do now, because when you showed me that photo, I remembered that 52 meters equals 52 centimeters. I didn't remember that.
Yep.
So what I can do now is draw a line from that on that 10-meter mark. I didn't do that last time.
Well,
so I have something to work with.
Depends on the height of the auto level, doesn't it?
Yeah.
Because that's the only height that you've got in the picture. I mean, that's what we do here. We do these little because it's you're doing geometry right now, right? You're using your brain to perform a logical task.
This was never something we disagreed on. So
good. Yeah.
I just didn't remember because it was well over 20 years ago, and we almost always used that digital one. So, yeah.
Well, that's what we're all about here. It's just that geometry. It's the practical thing.
Yeah, and I just brushed into it. So when you showed me that photo, it came back by all means. But it's been well over 20 years ago.
Cool. And can we address the shouting thing? I mean, did you turn me up too loud? Because I can't remember shouting or yelling, or I think you said
last
screaming
time it was
as well, didn't you?
So I had to shout. Just to get a word in, I had to shout. That's it.
No, you said I was. You said me.
Not now. I just had to turn it up because it was low.
No, yes. In the little presentation that you were doing where you were defending your model, your other model, not the big one, the little one, when you were defending that, you said 3 times that I shouted, screamed and yelled, I think. I can't remember what the other one was.
No, I don't say you shout. I said I shouted.
Okay, well, you said that I was yelling at you because your model wasn't correct.
When 5 people yell, I said all of them, as I said, used especially. But when 5 people are all over, it's a bit difficult to keep people apart.
Okay.
I didn't address you personally one-on-one. No.
Right. So
you guys.
You were sort of addressing your model, and then you were addressing my whiteboard and how that was equating to the water level test that we've got.
Yeah.
You do know we are testing the water levels like right now.
Okay.
Right. And we're 400 meters. Do you actually know the test? Have you seen it?
I've seen a couple of videos of it. Yes, I have a brief idea. Yeah.
Which videos did you see? Because I think the first one was the easiest one to see, the one that just had 3 water levels. That principle. If you want to work over the water level idea.
Yeah, but I don't remember which video exactly now. Sorry, it's been a long time ago.
Okay, so what would you like to go? Would you like to go with the basic one, and then I can explain the larger concept of what we have to deal with? And do you want me to get on the board?
No, you don't need the board. I have it in my head, and so you're gonna have 400 meters.
Yes, 400 meters.
How many tubes?
It's 4. Well, it depends if you call the risers.
Risers, yeah. Vertical tubes.
An extra if you call them an extra tube, then you want to know how many pieces there are and pieces and bits, or all together they are one risers. Body, like one. If you're talking about
water.
you're talking about the law of communicating vessels, right? Have you ever heard of that?
Communicating vessels.
Yes.
We're talking about one connected tube. All in all, everything keeps together. That's it.
Yeah. They say
Yeah,
like I say, have you ever heard
of those vertical tubes you're going to have?
Law of communicating vessels? Is the right line guru?
Doesn't ring any bells. Sorry.
Does it not? The law of. Should we? Do you want to Google it with us now? I'll have a go at doing it.
As long as we agree on it's one solid body of water, that's it. I don't need any more. One connected tube all over.
Yeah, that's the law of communicating vessels.
And we agree on that one. Good. How many of those risers are going to have? If that's the vertical tubes.
The principle of the law of communicating.
Again, we just agreed on that one. You don't need to have. We don't need to drag out the time, please.
Okay.
Just get to the point. How many tubes are we going to have?
All the liquid goes to the same level.
One body.
Yeah, it all.
Yeah,
equals
we
out.
agree on that one. I understand that one.
Okay, so basically, if you've got 400 meters of a water level, then the level of the water at one end is the same as the level of the water at the other end, right?
Yeah.
Now, all of those individual 100-meter risers that are in the middle, they're also at the same level as the two at the either end, right?
So you're going to have four vertical
Five.
tubes. 5. Thanks. That's all I asked for. That's everything else for the last 5 minutes. That's the one single answer I was 5. Thanks.
Yeah.
So, those are going to be level, yeah.
So 5 different
vertical tubes.
Yeah.
Just call it vertical tubes. That's it.
Well, yeah, they are vertical, but they don't have to be vertical, do they? Because it doesn't matter.
No, but that's what I mean.
The law of communicating vessels, Tommy.
Yeah.
Yep.
5 tubes that sticks up. Thanks.
In there for you.
We don't need all the definitions for the 5th time. Sorry.
There's a PDF in there if you want. You like science, don't you? Aren't you a man of science? Do you not like
I don't care
citations and stuff like that?
What isn't science?
Well, it'd be worth your while having a look up for the law of communicating vessels. It would be really good. And also communicating vessels. That'd be a good one for you to look up, and what the sort of accuracy of the instruments, right?
Speaking of that, I just sent I sent you a link in the comments about that one. You got that, as I talked about, where I said about the curvature and leveling.
What?
I'm going to do it again in the live chat. I'm going to find that.
Yeah.
Where? There.
Okay.
Open a new. Copy and.
And what's this that
paste.
you're doing? Okay.
Curvature and diffraction in leveling surveying.
Oh, from India?
I don't know where it's from.
Have you not got any from your country?
And this is
Because
where
I don't know how much contact have you ever had with these people, because
so India doesn't count now for some reason.
Ruhif was round here, and Ruhif sort of there was a paper wrote that said auto levels cannot measure vertical angles, plainly because they're auto level, they auto horizontal, right? But Ruhif then emailed this place in India, and they emailed him back saying they don't think they'll make a change, but Ruhif seems clever and knowledgeable about it. Does Ruhif want to come and help write some papers for them? So, yeah, you can't trust these Indian sites. I mean, have you not got a better one? Find us another one that not from this Indian place.
So because it's from India, you don't...
No, it's because it's not... They're not... I can't trust them. Ruhif, I did trust them, but Ruhif came round here and showed us that they will literally write anything some people want them to write in India.
How do you see this is from India?
Because it says Engineering Notes India, and it's got N Piriyakna Yanka. Sounds very Indian to me. I'd be I'd say that's Indian if like just a brief glance. I'm not clicking on it, but
again, you don't trust anybody. That's
so
not my
anything
problem. Sorry.
anything it says in there, can you verify it? Is that what you're saying? That's what the sort of notes and stuff that your practical experience
go that way,
of surveying was? No?
If you don't trust them, that's your problem. Sorry. Sorry.
Yeah.
As I said last time, you're a denier. That's not my problem.
I can prove that level is horizontal. I can.
That's exactly what I was talking about to the start of level.
Yeah, how do you want me to do it? How do you want me to do it? Logically? Geometrically? Well, again, I can't prove it practically.
I never disagreed with you. It's just that's local. Just locally. Move a few hundred meters and it's not the same.
A few hundred meters? What's not the same? A horizontal line isn't the same.
Because curvature.
Right, but you do realise a horizontal is a straight line. And a horizontal plane extends indefinitely. Okay, right. So how local is a horizontal plane that extends indefinitely?
Also, as I said last time, how microscopic do you want it?
I want you to tell me how large a horizontal plane is, please.
Indefinite.
Okay, so is that a local horizontal plane?
Sure.
Is indefinitely large.
Yeah.
Right, so at what point do you imagine that a straight line will start to lie without it?
Straight line is always straight.
Okay, and always lying in the horizontal plane then?
Again, if you move a bit, the horizontal plane is not the same. Because curvature.
The horizontal plane is the same. It extends indefinitely. You've just said that.
Locally, yeah, but if you move, it's not the same.
If you move locally, what do you mean?
Yeah.
How can you have something that is indefinitely large, right? Local. What's that mean? You can't put a size to it or a place to it or anything.
From where you're standing, that's locally.
Okay, right. Now, again, I thought we'd sorted this out at the beginning. When you say, can a straight line that is, let's say, straight lines which are parallel to the same straight line are parallel to each other, right? That's a logical statement.
Parallel lines never cross.
Okay. Now,
per definition,
a horizontal line is parallel to the same straight line, right? So, therefore, they are parallel to each other, right?
Except that the Earth isn't a straight line. That's it.
Well, the horizontal is parallel, like the very meaning of the word horizontal is the totality of the horizon, straight.
Yeah, no.
Yes, a horizontal is definitely a straight line because it is perpendicular to vertical.
The horizon isn't.
Well, it is parallel to. That's what horizontal is, the totality of the horizons.
No.
Yeah, that's what the tal means at the end.
Horizon and horizontal is two different words.
Right, well, if I look up for horizontal in any dictionary, mathematical, look up for the mathematical meaning of the word horizontal, because you trust maths, don't you?
No. Horizontal.
You don't trust maths.
Horizontal is a straight line. I agree with that one. Okay. No problem.
And it is parallel to the plane of the horizon, because all horizontal planes are parallel to each other. It's just a very simple fact.
Horizon doesn't mean horizontal. Horizon means just the parting of the land and the sky or something.
I'll get you a few definitions of horizontal.
Those two are two different words.
Horizontal.
Yeah, but it's two different words. Horizontal is straight. Horizon is not.
horizontal is...
Yeah, I don't deny horizontal, Bev. Please
okay.
understand. I don't deny horizontal.
Okay, well, parallel then, right?
It can't be because the horizon isn't flat.
Parallel is a mathematical term, right?
Yeah, but as long as the Earth isn't flat, it's not parallel.
But that's how horizontal is defined. I'll try and find you some mathematical
Locally,
definitions.
yes, at what place you're standing locally.
It doesn't say locally.
Well...
Does it say it in your one? Have you got anything to back up what you're saying right now? Because if you don't, you're looking like you're a bit... you're not coming with much. I mean, I doubt it your guys are looking in the chat at the minute, because you won't have that on, will you? But I am putting in definitions of horizontal into the thing now, right? And they all say a horizontal surface, vertical, an inclined plane, right angles to the plane of the horizon.
Locally.
Or a baseline that's vertical.
I really don't deny that. I don't see why you're doing this. I don't deny that.
Okay, so we're established that horizontals are parallel to the plane of the horizon, which means horizontals are parallel to each other.
Locally, yeah.
Yes, that's how surveying is. You say you've been a surveyor, right? You in your practical experience, did anyone ever tell you that the horizontals that you were using were not parallel?
First of all, we didn't work on that scale. We was on a building site on the Gardermoen airport. There was no, we wasn't going out. No, we didn't search for curvature. We didn't work like that.
No, nobody does. They just use parallel horizontals. I mean, I'm just saying what everybody uses when you use any of these tools.
Just like that place. Do you have sources for everybody?
Pardon?
Do you know it's everybody?
Do I know everybody? Yeah, every sane person. Yes.
Yeah, sure. But again,
so what is it exactly that you're saying then, right? Because you're not disagreeing that horizontal is a straight line. And I doubt it you're going to say that it's not parallel to the horizon, right? Because horizontals are parallel to the horizon, aren't they?
Locally.
Everywhere.
Who pasted this one? Earth is Life. Yeah. That's Earth is Life. Yeah. Horizontal line. Thanks, Earth is Life.
A horizontal line.
He is better at figuring this out than I am.
Oh, look at this one here. It's a mathematics one. It says a line with zero slope, or a line in which the y-axis always has a static value. The horizontal line is always parallel to the Earth's surface. Is that better for you?
But again, we don't disagree on this one, please.
Okay, so a horizontal, I mean, that's good. You don't disagree that all the horizontals are parallel.
Locally, it's of course the same.
Okay, so then we have to work on the meaning of your word locally. How big, if you had to put a value to locally, what would you do with that?
As long as you have 111 kilometers in 1 degree. If you had 10th degree, it's about 11 kilometers. So, how microscopic do you want it?
So, we're talking about from a horizontal plane. We are talking about, can you extend a horizontal plane? In geometry.
Didn't we just agree that the horizontal plane is indefinite? Okay,
but so it can be extended then?
Yeah, sure, why not?
Brilliant. That's surveying. So we're getting one step closer to the straight line test, right? Establishing the reasons behind the straight line test. Now,
because
go on.
That's what I asked. How many rises or vertical tubes or whatever
5.
are you going to have? You said
5.
Yeah.
Yeah.
So 1 in the middle and 100 meters towards the next, and 100 meters more to the one at the end. 400 meters.
Yeah.
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 So you really don't need to rent any surveyors or anything to put out a horizontal.
Nope.
That's that's just a waste of money as long as I can see it.
Absolutely.
Yeah, because the only thing you need to do is have a camera of some sort and just put that camera 100 meters away from the first one. Look across it.
No. You see,
Because if the furthest one...
No, we are proving it through geometry, right? Now...
why can't you do that?
Well, like I say, do you want to know the test, or do you want to tell me what you're going to do?
I'm just asking.
Okay. You're asking, why can't I do that? Well, I don't even know what that is.
As I just said, set a camera up 100 meters further away and look across it, all of it.
Well, what we're going to do is we're going to have people there with cameras, right? There will be people there with cameras. They can stand wherever they want. It won't affect the test. I mean, the test doesn't matter about that, because it's the shared straight line segment that we're involved in, right? Like I say, we work with geometric proofs when we do this stuff. We don't just look at things and sort of imagine stuff. We come with a backing from geometric proofs.
Wouldn't that be a great way to see the curvature, just to put a camera 100 meters further down and look at the risers?
That may be a good idea, but what we're hoping to do is to be able to teach people the practical use of right line geometry, right?
Yeah.
In Euclidean 3 space, where we all live, we're going to show, hopefully, the practical use of Euclidean geometry through the use of right lines.
Yeah?
Yeah. So
again,
step one, the first principles, is to work out a straight line. Can you make a straight line? That's the test, right? That's the test we've set ourselves.
And you're going to make that straight line of what? Water?
Yeah. Yeah, because if that's where you've got to go, right? That's the only place you can go to measure if there's any curvature or straightness, right?
How are you going to figure that out?
Geometry. Using the proofs of geometry, yeah.
So we're just going to take a tape measure or a rod or something, or measure from the ground up, or what are you going to do?
Okay. Are you ready? You understand the principle of all of the water levels together and linked up, and when you fill it up, all 5 tubes, the water levels out. Right, okay?
Everything's
now,
okay.
What you do is you get 2. And you shift it over. So right in the middle, at the centre, there are 2 sets of 100 metres. One from one level at one end, and the other one from the other one at the other end. So there's, in total, 600 metres from one end of the water level to the other. And right in the centre, there are 2 100-metre water levels, so 3 tubes that are interconnected. Well, they're not interconnected, they are together, right? To show that straight line in the middle has a shared straight line segment. And if, using the principles of Euclidean geometry, no 2 straight lines can share a common segment, is a proof within the geometry, right?
Is this going to be 2 individual tubes then?
It's going to be 2 individual 400-metre water levels. Yeah.
Side by side, next to each other.
Well, no, 200 metres shared segment in the centre.
Okay, yeah. But, so you're going to use
geometry
to... I don't have it all in my head, but yeah, sure, it's okay.
It sounds good, doesn't it? In
principle,
anyway. In principle, right? You can understand it, can you? Geometrically.
As long as the distances end to end is far enough, it's okay.
Because 600 metres. Well, have you ever seen the Ruhif numbers? I'll get them.
No, but again, 600 meters sounds pretty great. Yeah, sure. So then you're going to use geometry to figure out if it's straight or not.
Well, that's how you do shapes and lines and figures, right? That is geometry. That's what geometry does.
You just do it the easy way.
Geometry specialises in that measurements and shapes, straight lines.
Yeah.
Yeah. They're all defined, aren't they?
Down and watch all over it.
They're all well defined, and especially when Ruhif gave us the numbers, right?
Could you please stop bringing Ruhif into this, please? He's not here.
These are his numbers, right? You can check them. Ruhif just started them. Whatever helped out, Puppy Lover, and there was a few other people's. Brad the Science Guy. Yeah, there's loads of you. I mean, you can check them. That's why I'm giving you them, so you can check them, right? Now, they are a drop from horizontal. And as we've had everybody say, I mean, you've done surveying. If you're surveying and you're using a tool that establishes a horizontal, if there is a change in the vertical, what would you call that?
Well, again,
what would you call it?
Good question.
Do you not know?
If you want all of this to be a debate about semantics and definitions,
it's not a semantics. It's what would you call a measured change in the vertical when you are establishing leveling?
So we can say drop, we can say curvature, we can say a lot of things. But again, if I said the wrong thing, you're just going to be all over me. So why bother?
I'm not. I'm just asking you. Do you know? I will tell you if you don't.
Let's say drop or curvature. Choose one.
Elevation change. A measured change in the vertical when using a tool that establishes a horizontal. That is called an elevation change. That's the very principles of leveling. You measure a change in the vertical. That's what you do. Now,
yeah, but it doesn't need to be elevation. It can be drop or curvature. Elevation. Yes.
Okay, but that's why we're saying that's why it's vital we get the Ruhif numbers involved in this.
Yeah,
they've put numbers to it. Now, what sort of accuracy do you think when you were leveling, when you were practically using the tools, how accurate could you get your measurements to?
Also, as I said, just to point it out, we were never looking for curvature, just to make that perfectly clear. This was a building site. We didn't look for curvature.
Okay, so when you were trying to establish your levels,
and as I also said, when we went
how
from
accurate
point A
were
to
you?
point B,
how accurate
when we went
were
from
you?
Point A to point B, if we missed by a couple of millimeters, or 1 millimeter or something, we did it again. Yeah, that's all.
Okay, so you would be able to measure 3.1 millimeters then, right? That's 200 meters.
But that was with a digital auto level.
Okay.
If you're going to do it with a tape measure or a meter stick or something, I don't know. Sure.
Have you ever heard of the law of communicating vessels and the tools involved
Back to that again.
in communicating vessels?
Do you know disagree on that one.
Do you know how accurate they are?
That depends on the thickness of the tube and how viscous the water is and everything about that.
No, it doesn't.
If you have a small tube, you don't have the same accuracy as a big tube.
It doesn't mention anything like that in the tool. You should have had a look at it before. Okay. Well, one of the things that we've got is that they are accurate to a 50 millionth of an inch, I think. They come with like a little micrometer sort of thing involved with them. Go on, have a go. Google it. Right, so they're really, really accurate. Probably the most accurate things you can get. One of the most accurate tools there are.
When we doesn't disagree on that one, as I asked you.
Okay, so then you can measure then, right, these distances, right? You say you could measure 3.1 millimeters as a vertical change, right, from the horizontal.
Sure, why not?
Okay, so then the Ruhif numbers come into play then, right? You'd be able to measure the drop of the water level, because that's what these numbers are.
Yes, okay. I never denied it.
Brilliant.
Why do you stick on this? We never denied it.
Okay, well,
we agree on this one.
Yeah, okay. So when we go to prove our straight line in the straight line test, will you be bearing these numbers in mind to imagine a curve in those straight lines, or?
I probably won't remember those numbers, but
okay,
that doesn't make any difference because you will see if you have a camera on the other end if it will curve or not.
No, we will geometrically be able to show the shared straight line segment. Like you do realise that there's no such thing as a dark shark. We did make that up as a joke for Ruhif.
Never heard of that.
You've never heard of the dark shark?
No.
It's what we term as a sighted water level for people that want to be able to find curvature. The tool abusers, we call it. You know, like when you get a professional tool and you call it making a tool out yourself, where you just use it completely wrong for the wrong purpose, and
yeah.
You know, yeah.
But as we also agreed on, surveyors know what they do.
Yeah. I know.
Yeah,
that's what I'm saying.
Why are you going backwards?
I've done training. I have done a 2-year course in surveying.
Yeah.
So I've got a qualification. So I did actually do that. I mean, you just say you've got the practical experience.
Yeah, for 5 years.
Okay.
And I said we agree surveying works. So why going backwards all the time? I really don't understand why.
So surveying measures the change in the vertical, right? As an established change in elevation. So when Ruhif gave us these numbers, is that what you think Ruhif gave us? That when he said that that's the drop of the water level, Jesse Kozlowski as well, that the water level drops from the horizontal at a rate of 8 inches times the distance
numbers
in miles
are
squared.
okay.
You know.
Can we please step forward now? You're dug yourself in a hole. Get out of it, please.
No. I'm just saying they're your numbers. They're not mine.
Yeah, but the 5th time. We don't need a 6th time, please.
Okay, so the straight line test then, we'll go back to it. That when we have a water level of 400 meters and at one end, the far end doesn't drop, does it? There is no drop over the water level as it goes away from you.
From the first local horizontal, it will be a drop, yeah.
Well, see,
back to that one. Yay!
Water level dropping, right, is what you call an elevation change, isn't it?
Again, back to semantics. From the first horizontal, it will drop.
Okay, you imagine that the water will measurably drop from the horizontal plane established.
Let's just end this with one simple word: curvature. That's it.
Wow, that's not really going to cut it around here. That sort of a thing. Well, we deal in geometric proofs. You can't just use a word like that. You say we use semantics. That's ridiculous, dude. Ridiculous.
You just said what I have to say. You can't just use a word. You can't use horizontal or level or flat or anything. Just point the camera at the end and see that there is a curvature. That's it.
We're agreeing.
Your job is done.
No, because that isn't what you do with surveying, right? You should know that. If you've had 5 years experience in surveying, then you should know that that using the tools that establish horizontal planes and actually measuring things is much better than just looking at something with a camera. Right?
You're doing all this just to do it, and you're not looking for an end result or something. You're not trying to figure it out.
We're just going with right line geometry. Proving things for ourselves, yes.
Yeah, you're just doing this to do it. You're not looking for some result or some kind or something.
Straight
end
line.
Result. You're not.
Straight line.
What is
prove
the
a
goal
straight line.
Purpose?
To prove a straight line. To prove that right line geometry is the geometry of reality. To prove.
You're going to prove a straight line.
Yeah, geometrically you can. It's the only place that proof exists, really, isn't it?
But
logical proofs.
Next question, then, where is that straight line going to be?
What do you mean?
What straight line are you going to find?
The water levels.
The top of the water in the tubes is going to make a straight line.
Yes.
Okay, you're going to fail.
What? Do you want me to?
You're going to fail.
Do you want me to show you a plane in mathematics? Because we just use mathematic proofs, right? You don't like mathematic proofs.
As I said, Bev, please.
What?
This has nothing to do with words or definitions.
Mathematics you have to have a basis of things to understand, and the proofs of the words comes from mathematics. There's no other place to go.
No problem, Bev. Please, no problem. The thing is, if you are going to prove a straight line over those tubes of water, you are going to fail.
Okay, you say that. Is that because you think that we should be able to measure, or there's a curvature? You think there's a drop or a hump?
I don't think. I know it's a curvature.
Right. Okay. So, okay then. Do you go with the drop or the hump? Which do you prefer?
None of them.
What?
I don't prefer none of them. I prefer curvature.
Yeah. Okay. Drop or hump.
If you and I are standing a few hundred meters apart, there's no hump between us. There's nothing such thing as a hump.
Okay. So it just drops then. It drops from both sides.
Also, as I said last time, use any word you like.
Have you heard of the skateboard paradox?
No.
No, I think I've done a thing. Yeah.
But it just said words doesn't make any change. The reality is what it is. So you can use all the words you like about reality. It doesn't make change. So if you're going to use drop or elevation change or anything, it doesn't matter. It's still curvature.
That's not what the tool does, though, right? The actual surveying tool establishes a horizontal.
But again,
so
surveying works. You're going to find that.
Okay.
You're going to find
just
that
a quick one.
Straight line isn't
just
straight.
a quick one. How would you define curvature? Can you just have a go at that, please?
Define curvature?
Yeah.
A line not being straight? I don't know.
Oh. Not
define
that's
curvature,
really very well defined,
not flat.
is it?
I didn't give it a lot of thought, but not flat. Not straight.
Okay. How would you define straight?
Straight is straight. There's no definition for it. It's just straight.
Okay.
So, but again, I don't deny anything.
So you've not got a definition for something, and then you say for curvature, it's not that you don't have a definition for. That doesn't sound very. I know you did say you've never put any thought into it, but you're talking about curvature like quite heavily, and you're quite adamant that it's there, but you don't know how to define it. Like, what is it that you're looking for? What is it that you say is there? When I say a straight line, you know what straight is. Doesn't need defining. Yeah. You know what a horizontal plane is. That doesn't need defining at all. I've just asked you to define a curve. And you can't even define any curve. Never mind the one that you're imagining.
The only definition I had here was level, because
that's
many of people do think
that's not a circle. That's a straight line. Level is defined as a straight line.
Words doesn't change reality. So just because the Earth is a globe, you can define anything you want.
Dude, you didn't just pull out the Earth's a globe when you're talking about straight lines being straight, did you? Straight lines are defined as being straight, but Earth's a globe, so. Yes, you did. You just pulled out an Earth is a globe out your back. You started mantering.
Words doesn't change anything in reality, I said.
Yeah, but they do define reality. That's what we use words for.
Not if you misuse it. Not if you misuse it.
I'm not misusing the word horizontal. Am I?
No, but you misused the word level.
You are the one that just misused it because you want to make it a
there's a definition
circle.
for it.
It's not a circle.
There's a definition for it.
For level, yes, horizontal.
And following the curvature of the Earth.
But it says the curvature of the liquid parts, and then just a few, like we did before, just a bit before, it says the liquid parts of the Earth's surface are a horizontal condition. So therefore, if it conforms to a horizontal condition, there is zero curvature. I mean, zero is an amount of curvature, isn't it? For it to conform to, then it could conform to that zero curvature, couldn't it?
Go back a few seconds. What did you say? Where do you find zero curvature? Where did you say?
In a horizontal plane. There's no curvature to a horizontal plane. It doesn't curve at all. In fact, any plane as mathematically defined, a two-dimensional surface, does not have any curvature, does it?
This means that you can use the dictionary and be expert at
Just use maths, dude. Maths and geometry. I mean, how else do you want to define stuff? Especially shapes.
Yeah, but again, words doesn't change reality.
What's your reality?
Globe.
in your mind, but you've got nothing to back that up. You have to deny the obvious reality of level being horizontal.
Just scroll back. Give me a couple of seconds, please.
Okay.
I'm gonna find that. But if we can't observe the Earth, we can't measure the Earth, we can't calculate the Earth and everything else. So all you have to go on is that water level test. You don't have anything else but that water level test to figure out something.
Dude, what do you mean you can't? You just said you can't do things, right? Do you know the literal meaning of the word geometry?
This was something I asked you 2 nights ago, and you don't remember it.
Measure. So you can definitely measure the Earth. That's what surveyors do. I find it really hard to think that you might have been a surveyor, because you just literally said you can't measure the Earth, but you claim to have been a surveyor doing it for 5 years.
This was my words as your guys.
I've never said that, obviously. Why would I ever say that you can't do something that you obviously can?
When I brought up that Struve geodetic arc, which is measuring...
I've not looked at it.
You guys denying it.
I've not looked at it. Like I say, we deal at local levels, like where we are. Practical. That's all we do here.
Yeah, but then you're denying all of these measurements of the Earth.
Have you actually done that? Do you have practical experience of doing what you claim these people are doing?
I need to do measuring of the Earth. Are you serious?
I'm just asking you. You could just answer me.
No, I have never measured the Earth. No.
Well, that's good. I've never measured it either. Now, I won't claim it's true because I've never done it myself. You will never hear me claim that it's definite because I haven't done it. That would be a ridiculous claim for me to make. So you won't hear me claim that. Now, if you want to claim it, then you should really be open to people asking you questions about your claim. Shouldn't you?
But again, I can back it up with every observation I've done.
Every observation you've ever done?
Yeah.
What observations have you done?
Like the ones you tried your worst to rip apart last time.
What?
What?
Yeah.
So you don't remember 48 hours ago?
No, I've got a really bad memory. You want to see all of the stuff that's going on in my head, mate. We do loads of stuff here. We've got all sorts of projects going. This is it's like a design house. It's a workhouse. It's an idea factory. This place round here never stops. Go on, you'll have to give us a refresh.
I showed you these photos of my wind turbines. And I also showed you
photos.
that,
That's not a measurement, though, is it?
I showed you the photo of
it's just the photos.
Horizon across that.
It shows you could show us your holiday photos as well.
Yeah.
Well,
so I said.
I don't know. Like I said, I think I said, has Ranty shown you how to do that? Because you can't claim to be the king of optics just by looking at photos. I mean, please don't start putting rulers on the photos that you're looking at. And don't stare at photos for too long.
I'm going back to what I said for a few minutes ago. We can't observe the Earth. And you deny measurements.
What?
And
what measurements? What measurements do I deny? Please, which measurements do I deny? 33 meters. Oh, no, wait a minute, that's a good one. I like that. No, there's no measurements. Like, it's just a number.
What?
I'm asking you, which measurements do... you're saying that I deny measurements. Which measurements do I deny?
And I said it's through the geodetic arc.
Like I say, I've never looked at it.
Yeah.
Well, that doesn't mean I'm denying it. It just means I've never looked at it. And I can't do it for myself. So I'm not denying it. Please don't put words into my mouth. I won't do the same to you, Tommy.
You've never done it for yourself, so you just,
well that's a true statement, isn't it?
Triangulation between northern Norway and the Black Sea. It's on Arabic or something, I don't know, but that's where they went. And they found the curvature.
Okay. How did they find the curvature? Please run us through the method that they employed when they did that.
Triangulation, surveying.
Triangles with straight sides.
Straight sides.
Yeah. Okay.
But seriously, you're a surveyor.
Yeah.
Have you ever had straight sides like 60 when you're triangulating?
Well, you want to get them as even as possible, don't you? The angles. You don't want to be using an out of proportion triangle, definitely whenever you're using triangulation. Yeah, but always straight-sided triangles. I'd agree with that. I mean, that works perfectly with right line geometry, right? Straight lines. We love straight lines. And the mathematical proofs that state a triangle always, like without fail, has 180 degrees. No more, no less, ever. Because that's how a triangle's defined, isn't it?
On a flat surface, yeah.
Just a triangle.
Again, if you click on that picture, you can see the bigger version of it.
Okay, so a load of triangles they've got. They started off with a baseline, and they triangulated loads of triangles together, right? Along that line.
And again, these were surveyors. I think they know what they did.
Yeah, they made a load of straight line triangles. Yeah, I get it.
And along that way, they found, what it says, 26.43 degrees of curvature.
Do you think? What do you think they were measuring when they were doing the actual surveying, measuring the triangles?
They found curvature. That was what they was going to do.
Is that what they were looking at? Do you think, or do you think they were looking at something else while they were also doing that?
That's what they were looking for.
Oh, they weren't looking at any lights in the sky whenever they were doing anything. They were just triangulating triangles together all the way across, right? Surveying. Yeah.
Yeah. Surveyors do.
Yep.
Yeah. So
they just made a load of triangles and used a load of straight line triangles, and they connected all of those up all the way along there. And you say they came to the end and decided. Oh.
Decided? Who said decided?
Well, I don't know. What are you saying?
Found.
They found. What did they find?
Again, you're a surveyor. If you're going out for surveying something and you've done your surveying, you don't decide what you have found. You have found something, you calculated it. The result, you don't decide the result.
Okay, so Do you imagine that you can use straight line triangles to... Oh, actually, have you ever heard of Gaussian curvature?
Gaussian?
Yeah.
Gaussian
curvature.
Magnus or something.
It's Gauss. Have you heard of Gauss?
Gauss, also in distortions on Photoshop elements, but no.
Oh, right. Well, Gauss, he was a famous mathematician. And as all mathematicians, they always go for geometry. It's the age-old problem. When I say problem, yeah. What Gauss decided was that you could tell the curvature of the shape that you were on because you by the amount of angles within a triangle measured upon the surface. And it turns out that if it's on 180 degrees straight line triangle, that's Euclidean 3 space and therefore on a plane.
That depends on the size, doesn't it?
Well, in maths, in reality, and obviously in reality, because that's what we talk about when we maths. You know what 3 non-collinear points would make if you join them up?
I'm not a mathematician, so we don't need to go that way.
Okay, well, 3 non-collinear points would turn into 3 coplanar points. So that's means that a triangle, whenever you make 3 points and join them up together to do surveying and measure the angles, they always have 180 degrees. So you can't use triangles of 180 degrees to prove that the triangles don't have 180 degrees. Sounds a bit ridiculous, I know, but I mean, that's just maths.
Yeah, but when MC Toon made his flight charts over a globe with 3 90 degrees angles, with 3 straight lines with 90 degree angles, this is what it ended up with like someone had in chat time now.
Did you say McToon?
MC Toon, not McToon.
It's McToon, he's Scottish.
No, he's
not. He's not an MC. Definitely not. He said he's not an MC. Definitely.
He's the worst rapper in the world.
He's not. It's not even
again,
that. That isn't. That's not straight lines, right? They are not straight lines. And then you have just said that you're not a mathematician, right? So please don't go to areas that people are feeding you. Who have you got helping you? Anyone?
No one.
Because I'd say, well, don't accept help from McToon, because McToon drawing lines on balls doesn't prove anything geometrically, and it definitely doesn't help you prove spherical geometry.
As I said 48 hours ago, you pull in a whole lot of people, but I can't. I see that. That's kind of cute. Is that a straight road or not?
It's got look at the bumps in it. It's a lumpy, bumpy road.
Is it straight?
It's a lumpy, bumpy road. It's not straight, is it?
Of course,
that's not a straight. That's not a straight line, is it? Yeah. No, you can see all the lumps and bumps in it.
So definitions of straight can be different.
No, straight is straight, and that is not straight.
It can be straight in the left or right, but it's not straight up and down.
No, it's not. It's not straight. Now, if you were to draw a straight line from the start of it to the end of it, then that would be straight. But that would be the straight line that you draw from the start to the end of it.
But that you can do with any curved or a lump of yarn. You can have 2 ends with a straight line between. So yeah.
Dude, that's not straight. That's that's Xanic levels of incompetence.
But then we have to go to the definition of straight, don't we? But
okay, again, then if you want to go to the definition of straight,
no.
We go to Euclidean geometry. I mean,
but that's
it's sorted in there.
you can have a triangle with more than 180 degrees.
You
as long as
can't.
it's
A triangle, there's a proof in mathematics. Triangles only have 180 degrees.
Then you're back to all the... and again, I'm not a mathematician, but there's something with that Euclidean stuff and something else on a globe, and you can have a triangle on a globe.
Dude, you haven't got the magic wand you think you have round here. That's not going to work.
I'm not going to say I have one.
Okay,
but,
well,
again,
dude, there are no globe geometers. They don't exist. Don't pretend you are one. It just doesn't happen. We just deal with reality, and let's just go from there.
Reality is when you have that water level, you won't find a straight curve. That's it.
You won't find a straight curve because there's no such thing.
Yeah. You find for the straight line. That was yeah. You won't find a straight line. Sorry. You won't find a straight line across those.
We'll find a horizontal plane.
Oof.
Yeah, you're right. We will find a horizontal plane. Look up the law of communicating vessels, please.
Yeah, but again, words doesn't change reality, does it?
No, reality is reality. There's only one reality. Yeah.
Yeah, and that reality is when you have those water tubes, you
we
will
use
find
words to describe it, dude, don't we?
But as I just said, when you set up that water tube, you will find that you are not a straight line.
Okay, that's what you say.
So again, we don't need any definitions for any words or anything. As long as you have 400 meters of water tube, which will then have a 3.1 millimeter difference, you won't find a straight line. That's it. Simple as that.
Right, well, when the paradox of the skateboard paradox that leaves you with the drop or the hump, it's like a logical paradox, right? I can't understand how you keep trying to miss it. You keep trying to avoid it as though it's semantical, right? It's not.
What is it?
It's a logical paradox that you guys have.
Yeah, but I never heard of it, so yeah, I don't know.
Okay, well, let me see if I can find some pictures for you. I'm trying to
make, but again, paradox is
trying to make a brew.
Good afternoon.
Yeah, Rob, this is a 1v1, Rob.
Yep. I'm just coming in to say hi.
All right.
Hey.
I'll be quiet.
Thank you. Hump.
Yeah.
Gentlest channel. Hump.
Yeah. Oh, we like the big pop of the P at the end.
Hump day.
Right. So.
Yeah, but again, hump, drop, tangent. Yeah, sure.
See these two guys here. You've got the East Side DP and the West Side Guru. Now they're both obviously one's on the East Side and the other one's on the West Side, looking at each other. Right now they're seeing a drop, right? That's what you say, according to your model.
If they are looking to each other, is the drop between them? They won't see each other.
But there is. That's what you imagine, right? There's a drop. Yeah.
Curvature, yeah. Just call it curvature. You don't call it drop or curvature or hump or whatever.
Okay, so there you go. They're both together. This time we've swapped it up. We've got a turban mug and Chihuahua on a skateboard. It's Rob Dessie's hat. Right, so they're both looking at each other. And there's a drop in the middle. Oh, see, now Gently's channel's got a different one. He's got a hump. See, there you go. There's perfectly explained. Well done, Gently. Thank you very much. The top picture describes the drop that you imagine. But when you get two of them together, right, looking at each other, you've then got to go to the hump. Like Gently's describing, right? That's the paradox. That's the logical paradox that you've got. Explained perfectly by the skateboard paradox, right? Because at one end of the bridge, you're going downhill. And if at the other end you're going downhill, but you can't go to a drop in the middle at the bottom in the middle. So you've got to go to the hump in the middle. I mean, it's a.
How are you going downhill from both sides?
You're not going downhill. That's why we've put the horizontal on our picture. See that as well there. Gently's channel, he's put that in. Yeah. He's got a chord, right? And I know you're not very good at the geometry because you have said that. But you see the fact that he's put a chord.
I said I'm not an expert.
Yeah. Do you know what a chord is?
Yes, it's a chord line down there, yeah.
Do you know what it is, though, a chord?
That would be in the triangle I had from one point to another through the Earth.
Okay, now, look at you, Ranty. Ranty's telling you some globe head geometry.
Yeah, but again...
There are no chords in spherical geometry. They only exist in Euclidean geometry, chords.
Yeah, but again...
So if Gently's put a chord there, then he's obviously talking about Euclidean geometry. And you know what happens in Euclidean geometry? Boats don't float on balls. Because water isn't curved in reality, Euclidean 3 space that we live in.
Just to repeat myself for the nth time, this is... all you guys do. You have words play and definitions and drawings with words on it and different stuff. So, after you have done that,
logic and reality, test, dude. That's all we're doing. You're not happy with it.
Words isn't reality.
Fill in your own excuses then for what we're dealing with. Look at Gently's doing a triangle trick. Are you happy with that one? Do you like that? Do you know what he's doing? That's the perfect maths that, according to Fight the Flat Earth.
I have no idea about cosinus and sinus and yeah.
Whoa.
But
it's a bit above your pay grade, is it?
Not everyone's a mathematician. So sorry.
Okay.
Serious question. After you have done that water level test.
Yep.
And you have measured and found and seen that the middle one is taller than the others.
Yep.
What are you going to do?
I will go and find somebody else that has a 400-meter water level. Go and join up with them. Help them prove the same. We'll just repeat.
Okay.
Yeah, because that's another one of the... you like science, don't you? Isn't that one of the things? Repeatable, isn't that one of the...
It's not that I like science. I don't care too much about it in that way that I'm fanatic about it. Science is okay, but... yeah, science works.
Yeah. Well, after we've established the horizontal, the water level can establish a horizontal, then what we'll do is we will go to somewhere like Bedford and set up some boards horizontally and look at it over a large distance to see what happens and optical drop. And we'll see. We'll be able to do that because we'll be absolutely certain that we're on a horizontal plane with all of the markers.
You're not going to do that in the water. You're going to be a few feet above the water.
Yeah, you don't do anything in the water, do you?
As the Bedford level did in the water, just above the water. Bedford, you said you're going to Bedford.
Oh, I've already been.
Yeah.
Yeah.
So the Bedford level experiment, the first one, was done...
Experiment?
Just inches above the water.
Experiment?
Call it what you want.
Yeah, go on. We'll start off with the naturally observed phenomena.
Robotham was it, yeah?
Yeah. If you want to call it an experiment, go on. What's the naturally observed phenomena that he started off with?
Something, call it what you want, please. But that was just inches above the water.
Yeah. We did. That's what we did when we went. Yeah.
Dead in the middle of refraction.
Yep.
Yeah.
Yeah. So do you think Robotham actually did what he claims to have done?
As far as I read about the experiment, it was just a few inches above the water.
His telescope.
Just a few inches above the water. That was all.
How good was his telescope? Do you know?
I don't know.
Oh.
But again,
do you think it was better than a P1000?
the optics wouldn't do anything about reflection.
Do you think that what Robotham has claimed to have used when he was doing his observation...
Better than a P1000? What would have been better than?
Would it?
P1000 is a shitty camera.
It would have been better.
In what way?
Well, like, he was in the water, inches above the water, claiming to have done something. Now, we have been there with a P1000 inches above the water.
Yeah.
Do you think which one's best? Robotham's telescope or the P1000? Which one would you reckon?
Better in which way?
For seeing, looking down the canal.
Yeah.
Yeah, because that's what he was doing, right?
Yeah. What zoom do you have on a P1000?
It's 125 times. Optical.
What does that? Yeah. So, in millimeters of focal length, what would that be?
I haven't got a clue.
They say about 3,000 millimeters.
I haven't got a clue.
You know why that is?
I don't know. What did Robotham have?
I don't know, but I know what a P1000 is.
Okay. So,
P1000.
what did Robotham see?
Let me please explain a bit about the P1000, which you said is so good.
No, it's just like, dude, it's my lad's camera, right? Then he's got the footage from it. So, okay, now that's established, right? There is footage from my lad on Bedford Level Canal with a P1000 inches above the surface of the water, right?
Yeah.
With somebody in a boat going away, travelling, moving away. Right now, that footage is there. It's viewable. It's seeable. Now, what do you imagine, or maybe maybe they took some pictures or something, when Robotham, because you're the one that brought the Bedford levels up. What have you got to say what Robotham did when he was claimed to have done what he did, right? What's the story behind it? What are you bringing with Robotham by mentioning the Bedford levels?
Because you said we were going to Bedford, and I just asked if you're going to keep a few feet off the water and not just inches.
No, that was a completely different thing. You're thinking on the water. I'm talking about a completely different optical test. Because that's where the bank is that we will be able to use, right? It's the longest, straightest thing for us to be able to use. 3 miles.
The bank is a little better.
Yeah.
Than being in the water.
So for the opticals, right? But you claimed that Bedford, right? It is a canal. That is a 6 mile stretch of canal in a straight line, dead straight line.
That's when I asked if you
dead straight in both ways, really.
Yeah,
dead straight line and a horizontal plane as well.
Yeah, so sure. So that's when I asked if you're going to stick down in the water like he did, because he was inches off the water in the middle of refraction.
And what do you think he saw?
Longer than he should. Because refraction.
You think he saw further than he should?
Yeah.
Well, you'd be sorely mistaken. That isn't what happens when you are so close and you have such a limited angle for your view. You soon enter the mirroring stage. Now that it doesn't mean it's going over a curve or it's dropping away.
But again, it's a zoom. Let's go back to that P1000 so you understand reality. P1000 has a said to be 3,000 millimeter zoom. Oh, it's so gorgeous. The thing is, the physical zoom of that camera is 560 millimeters or something like that.
Dude,
because
there's no need for you to go and do this. I mean, it's my son's camera, and when I bought it, I asked them, I said, what can I expect, right? Can we get anything close to this? And the fella said, not a chance. You would have to pay thousands for lenses, and you would have to have different swappable lenses. There is no other camera that's comparable to the P1000 for this price. And I went, okay, then that will do.
Do you know what a crop factor lens is? A crop factor sensor is?
I haven't got a clue.
Oh, precisely.
Do you have a P1000?
As I said last time, I'm pushing that button on a camera for 20 plus years. I know how it works.
Okay, so what camera do you own?
As of now, I have 3 or 4 cameras actually. One I use most is the Canon EOS 70
You must have a
Mark
lot
II.
of money.
No, I've saved over the years. All my cameras except one I've sold. Sorry, I sold one.
Well, you said you've got 3 or 4.
Yeah, and I sold one and I kept the rest.
Okay, so you've
years.
got a lot of cameras. That's nice.
3, 4, yeah.
Very good. What's the best one? What's the best one with the biggest magnification zoom lens you've got?
Cameras doesn't do that. Lenses do that.
Okay, what's the biggest lens you've got then? Come on.
100 to 400. And again,
100 to 400. Zoom.
Can I have the word for just a few seconds, please? Mm-hmm. The reason why flat earthers think that P1000 is such a great camera is because of that zoom.
Why are you talking about flat earthers, dude? You just told me before, right, to not mention Ruhif because he wasn't here. Now, why are you mentioning flat earthers? Are you that bigoted? You just have to keep bringing them up.
Okay, strike that one. Yeah. So, the P1000 has a physical optical zoom of around 560 millimeters because that crop factor sensor is the sensor inside is tiny as your pinky fingernail or something. So that means that zooming is effectively a lot larger. If you take all that optics and put on a full frame camera, you have a 500 millimeter zoom. So it's a shitty camera in all sense and purposes. But
my lad likes it.
Of course, I wouldn't.
Have you ever seen the? Have you ever seen a Fata Morgana sunset?
I said sunset with some distortion to it. Yeah.
Right. So have you seen them? Have you got a film?
No.
No. Why is
we don't
that?
have those conditions in Norway.
Okay. You don't get those conditions.
I don't think so.
We did.
But
and
if
we hadn't have got the P1000 and we hadn't have had the P1000, we wouldn't have took the shot. So it depends, doesn't it? It depends what you're after. I mean, it depends what you call value of, and what you call what you want out of the thing.
You could have used any camera and then cropped it.
I couldn't have got any camera because you can't get the zoom with any camera.
No, but as I said, you can take any camera and then you can crop the photo afterwards. That's the same thing.
It's not the same thing at all.
Yeah, it is.
No, it's not. I mean,
the details.
It's a fantastic piece of kit that's allowed us to take some shots. Like, I mean, Isle of Man, 85 miles away. What's the furthest shot you've ever seen?
The wind turbines were about 68 kilometers away.
85 miles.
Yeah.
That beats you, doesn't it?
I can still have details at a distance, but I just have to crop it. No problem.
Mm-hmm. Yeah. I mean, say...
zooming is magic now.
No, it's not that's the thing. It's the ability for you to see things that you would never have been able to even imagine before with a camera that has such a zoom.
Again, zooming isn't magic, so I can do the same with my camera and just crop it afterwards.
Yeah, look, dude, I don't I don't want to sell the P1000 for Nikon. I don't think it needs it, to be honest. I think it does it well enough for itself. But the fact that you're trying to diss a camera that's been made by Nikon, I mean, like, why are you doing that? I mean, does that not seem a little bit... I mean, nobody's claiming anything, right? The only people that claim things about pictures are you guys. And Ranty, obviously. Ranty now. Right? They're just pictures. They are literally just pictures. No, we don't put rulers on them or anything. We just look at things and go, wow, that's nice. That's a nice picture.
When you take a picture of something at a distance, it's nice and clear without distortions or anything. Wouldn't that prove something to you?
It's a nice picture. Normally, what we say. Yeah. Oh, that's
because
a nice picture.
If those turbines of mine were full of distortions and stuff, we wouldn't use those. Just like that, you have seen that Skunk Bay video, have you?
Yeah, have you seen the Nugget, the Blackpool Nugget GIF?
Don't sound familiar.
Do you not? It looks a bit like Skunk Bay, a bit.
Yeah?
Yeah, with the Southport Blackpool moving up and down.
Yeah, that's how distortions work.
Yeah.
So you can see in a photo or video that there is distortions.
Yeah. You can see that. You can see that definitely through the camera. Like I say, we've been to Bedford. We've had the camera inches away from Bedford as the guy's going away in the dinghy. Right? We've seen that.
Yeah.
Yeah.
So
are most people that are in here. They've also seen the similar. They've seen it. The same video.
48 hours ago, when we looked at my photos of those turbines, there really isn't much distortions going on in either of them. So when you guys say that is refractions and all of these things happening through the air, that the atmosphere plays havoc on something, that would show in a photo, most definitely.
Yeah, photos, that's what photos do. Photos show things, don't they? They take a snapshot, a freeze frame.
I don't know if it's you who said it. You have someone with the same voice as someone else in there, but that other guy said something about the atmosphere plays havoc on photos.
I don't think it would have been anybody in here. We don't use that. It's a dirty word, the air.
Yeah.
The low air, heavy water-laden air. Yeah, I'd say that. Definitely.
Would water make a difference?
Pardon?
You said water in the air.
Yeah, water-laden air. Yeah, heavy water-laden air. Yes.
As in fog type.
No, the water that causes a haze. The water that causes the mirror.
Haze, fog is not the same. That probably some difference in English.
No. No, have a look in the live chat.
Yeah.
You see that mirroring? That's not water. That isn't water.
Now that's mirror. That's something of the again. Those are distortions of the camera. You can see there are distortions.
Yeah, that's what I'd say. That's what we do. We look at. That's what we look for in the camera. And guess what? With the P1000, it's there always. Because you have the focal length to be able to get into that bit that you can't normally see.
Yeah, but again, when you have a proper camera with a proper sensor inside it, you can crop out and see exactly the same.
Well, what is it that you're seeing? What is it that you imagine you're seeing?
If I stand beside you when you shot that photo with my camera, even though it's only a 400, because of my crop factor lens of 1.6, that's a 640 millimeter lens. And if I cropped my photo to match yours, I would probably still have a better quality photo than you have.
Yeah.
Because that chip inside that P1000 is a shitty little thing.
Okay.
To be honest.
Yeah, my lad's happy with it though. I mean, you see the places he's got with it, where he's been. Have you ever been to Bedford Levels?
My
lad has. That camera took him there. Have you ever seen anything 85 miles away? Well, guess what? We went to the top of the local hill and saw it. We got there. That was the camera that did it. Camera took us there. Yeah, sure. The cameras took us to Southport to take pictures of Blackpool Tower.
Do you think you'd ever will see a professional photographer with a P1000?
I don't know. Why would you? Are you saying my lad has to be a professional photographer?
Stop bringing your lad into this place.
Well, no, we're just talking about a P1000 right now. What is your beef with the camera?
It's a shitty camera.
Okay, brilliant. You don't have one, do you?
No, I wouldn't have it.
Brilliant. Listen, well, that's good. Also, right now, do you have a problem with somebody else having one of these cameras that you consider shitty?
I don't have problem with it on the persons.
Okay, then. So you just have a problem with the camera. Take it up with Nikon. I don't give a shit.
If I was standing next to you on that hill and I took a picture of the same thing, I would also see the exact same distance. You don't see further with a P1000. That's not how it works.
Who said you did?
You said it something 80 miles because of that camera.
Just seen it. You've just said that. I didn't say it. I said we have seen something with that camera through the lens of that camera. Now, when we were stood there looking with our eyes, we couldn't see it. Yeah. So the camera gave us the ability to see it.
Yeah.
Yes.
You said because of that camera.
Yes, because of the camera.
Yeah.
Had we not had the camera, we wouldn't have been able to see it.
Well,
in regards to the Fata Morgana, if it hadn't been for us starting the Try Thinking channel up and having the camera, we wouldn't have gone to Southport Beach to take the TT shot with the silhouettes and then go, oh my God, what's that? What's going on there?
But again, you can't say because of the camera.
I can't, definitely wrong. For that one, yeah, absolutely. Logos driven all the way, 100%. We were meant to be there, and we were meant to be there with a P1000.
Yeah. But then I have a suggestion for you. A serious one. When you do that water level test, take that camera and place it 100 or 200 meters down range from that and just look over it. Zoom into each one of those.
It's a water level test, right? The principles of the law of communicating vessels and the beauty of a water level means you don't have to sight it. You can be confident that without a line of sight, you can be confident and sure that a horizontal plane will be established through all interconnecting vessels.
Yeah, Back to that one, as I never disagree on.
Yep.
But as a serious test note, just try that, please.
Try looking at it.
From one end.
We're taking some pictures. Yeah, I mean, like he'll be there taking pictures all day.
Yeah. So just
that's what he does. He's on the camera. Yeah.
So just set it in line with the water test, not perpendicular to it, but in line, 100 or 200 meters down the road or whatever you are. Just look along those tubes.
And you think it'll be dropping from either end?
You will see the middle and the two in the other middle will be higher than the one on the ends, yeah.
Be higher? The middle will be higher?
As I said, when you're standing at one end looking along that line, yes.
I thought it drops if you're standing at one end. It's only if you get somebody on the other end, it turns into a hump. Do you not know your models yet?
But of course, the one in the middle will be higher than the two others if you have a camera at the end.
No, you need to have a hump. They're all dropping, don't they? Like on your one model, one person model, the water level drops because you're always on the top of the ball. Everywhere it drops away from you, right?
We're talking about 3.1 millimeters, wasn't it? So
a drop.
If you have that camera,
yeah, that was a drop from horizontal, not a raise. That was a drop from horizontal over 200 meters.
Yeah, stop with the words and semantics, please. So
no words. This is geometry, dude. Just stop saying that. This is mathematics and geometry.
Yeah,
it's the most exact thing there is. This is where proofs were generated, right? This is where the basis of mathematics comes from. The proofs gained from this, logical proofs from reality. Yeah.
Can I please continue? Thank you. So, when that camera is on a tripod, let's say 100 or 200 meters in line with that water tube test, and if you lift or drop that camera with a centimeter or something, it will either be a drop or a hump, because then it will look at that water from different angles. That's perspective for you. So if you have it in line with both ends, the top will be higher. If it's in line with just the front one, the other one have a drop. That's just raising and lowering the camera with, let's say, a centimeter or something. Not more than that.
Sorry. Gently's put a thing about the water level, just in case you thought it wasn't, tests weren't being done. Gently's done a thing there.
Just to point something, as I got a hell of a lot of beating for when I first did this with my water tubes. When you have a thin tube like that, you will have that meniscus. So either use wide bottles or a wider tube, so don't have that meniscus problem. Because that's going to ruin a couple of millimeters.
Yeah. Like, you don't think that's... I mean, what do you think that is? The Gently's got there.
I see some tubes with water, but...
What do you think they are, though? I mean, it's just 5 tubes with some water in. What do you think it is?
I don't know. Tubes of water.
Just tubes, just like straws.
As long as it's cropped, that I don't know. I can't assume anything.
Why do you think he'd be posting it?
I don't know.
It's weird, isn't it? It's really weird what some people do. He's even wrote like water is level and horizontal as if he's like a special person. When he's just cropped a photo that doesn't actually explain anything. It's really weird.
What is the distance between the tubes?
Which tubes? There, look at it. They're close together, them ones, aren't they?
Yeah. Mm-hmm. But as I said, those tubes are small and you have that meniscus problem. If you have wider tubes, you don't have that problem. That's it.
Yeah. You still get a meniscus, don't you? Capillary action will always draw the liquid up to on the surface at the side.
Yeah, but
through
you have
capillary action. Yeah, that always happens. Yeah,
or if you have take a bottle cap and just cut off the bottom of a bottle and turn it upside down like I did, so you won't have that problem as much.
Wow, you seem to know a lot about communicating vessels.
I figured that out first time I was there because I had tinier tubes and there was a meniscus.
How big was your tube then? How long?
The first is the diameter. The first.
How long?
3-4 meters the first time, but again there was a problem with the meniscus. The length.
It's a problem with the meniscus. No, it's the same. It's the same tube. It'll have the same meniscus on each side. Water will always even out, won't it?
Yeah, that's why the length doesn't matter. It's the diameter.
No, the diameter doesn't matter either.
Of course it does.
No, it doesn't.
If you have a smaller tube like I had the first time at 10 millimeters,
it'll just take longer to equalize, but it will equalize.
Yeah. But look in that photo, the top one without the red ones.
What? Sorry.
You have a thinner tube. The tension of the water will make a meniscus.
What tube? Yes, dude. We are testing water levels now. What do you want to know about them? Because we can tell you. What sort of a difference do you think there is in between a 3mm tube ID and a 5mm tube ID? What do you think?
3 or 5 millimeters. Yeah, we will have that tension in the water. What's it called? Surface tension.
Yeah.
So the smaller the tube, the larger problem we have within the meniscus. And I didn't know that the first time I did this, so I got my ass kicked for that.
What's the difference between the meniscus in a 3mm tube and the meniscus in a 5mm tube? With regards to them, the water leveling out.
I can't calculate it, but again, the first time I used that 10mm. And then there was a meniscus AF, so I switched up to a 15mm tube with 2 bottles at the end, and you won't have that problem. It's just water tension, surface tension.
Yeah, like I say, have you looked up the law of communicating vessels yet? Because you keep saying this, and you keep acting as though you are. Not knowledgeable about these sort of things, right?
Because I learned from the first time I was out.
When you were out where?
At the end of the world with my observations.
At the end of the world?
That's his name, actually. The end of the world. That's his name.
Okay.
Where I have this wind turbines at a distance.
Okay. Have a look in the chat now then. Have a look in the chat. See that?
Yeah, that's better.
What do you mean that's better? That's better than what? That's just part of the testing we're doing. Now, I'll say it again. Have you looked up the law of communicating vessels yet? Or not?
No, because we don't disagree on that.
Okay, so given the fact that you can see from that we know what water levels are, and we obviously know more than you about the law of communicating vessels, and we've also tested different types of tubes and different temperatures and different conditions and different sizes and different makes, obviously, and equipment to stop the leaking and all of that, because that's what we do. We test stuff thoroughly because we want to do stuff properly. Cool. Right, so let's, given that we already know, right, so can you now please stop the condescending tone with you trying to teach us something, right? Because you wanted to come and ask us questions, didn't you?
Because the 2 first pictures there from Gently's channel show a meniscus on thin tubes.
Yeah, that's because Gently, like you say, he doesn't give you any context. Gently doesn't even know what it is. He's just picked a picture up, right, of some testing that we were doing, and he's imagined that it proves that water level isn't horizontal, because he doesn't understand anything that's been going on. But that's Gently, right? So you've got to be very careful about what you read and what you look at, especially within pictures from people that are butthurt about reality. Please don't take what they say about us genuinely, because they've not been round to ask about the test properly. They don't understand what we've been doing. We've been out on the canal like quite often, live. People have been able to come in and talk to us as we're out there in the field doing these tests. Auto levels, water levels, auto levels and water levels. We've done multiple different tests out in the field.
Yeah.
Yep. We do have practical experience. We have people that are very practical in what they do.
These vessels are communicating.
What are you doing now?
That one is just, if you have a normal, what do you call it, sucking something liquid with the mouth, straw, there's a straw. You put that in the water, and the water will rise above that level in the glass or whatever.
That, as we keep saying, do you know what's going on in that picture? Do you want to have a go at explaining it?
I know what it's called in Norwegian. It's called hårrør, also hair tube, something. That's the surface tension of the water.
Okay, so that's not water level, is it? And that isn't the law of communicating vessels, is it? Because like you said, it depends on the diameter of the tube.
Yeah.
And it definitely cannot have a different diameter, can it? Especially when you start getting down to the capillary action part.
Capillary, capillary, yeah.
Because that's the meniscus of it. Every liquid has a meniscus, a curve, where it will pull up the surface. Now, once you start narrowing the diameter of the tube so that meniscus or that little curvature starts meeting each other, then it's called capillary action, where the water will rise up the tube of its own accord due to this meniscus effect, the capillary pull of the water up the side of the surface of the tube.
Yeah, and that's exactly what I was talking about the first channel photo with that water was not level in the tubes. That's because of the tubes are too thin. That's exactly what I'm going to show.
No, that wasn't what was going on there. That wasn't what was going on when Gently was doing that test.
Yeah.
It wasn't. Or is that what you think? Okay.
So that
you've seen that picture of 5 tubes next to each other, and you've come to a conclusion, like Gently, have you, that you've decided what was going on?
Because in the middle one there, the water is crooked. It's tilted.
Which one?
The water is tilted.
Are you going back to my picture now?
The two from Gently's channel with the 5 tubes. Because in the middle one there, the water is tilted. So something is going on because of the surface tension. That's when I pointed out that...
Do you think all of those tubes are back against that yellow thing?
I don't know, and I don't care.
Oh. Do you think one of the tubes or more of the tubes being closer to the camera might have an effect?
No.
No. Really?
Say that's surface tension.
Are you assuming that the lens of the camera is directly in line with the water level of those tubes, and therefore...
That shouldn't have anything to say.
Really?
Yeah. I said the tube is too small, so surface tension. That's it.
Okay. That's nice. Did you ask the person that was doing the test or what was going on?
Oh, but that's how I interpret it.
Yeah. Like, who's that other guy? Ranty. He finds pictures on the internet and interprets them however he decides he wants to interpret them. And doesn't ask the guy that took the picture anything. And yeah, you've done the same. It's nice. I like this. I like this. It's the, what do you call yourself? The Glarpers, I think. You and Ranty as well.
What?
Glarping, yeah.
What's that?
Your Globe live action role players.
Okay. Sure. Whatever. It's nice to have nicknames. Flatards, Globetards, Glarps. Yeah. Sure.
Well, it's not flat, right? You do know that. Because Ranty, that picture that Ranty found on Facebook's got mountains in it, hasn't it?
I have no idea what you're talking about.
The picture with mountains in. I've got one. Do you want me to get it? I'll get you a picture of...
Oh, the Blackpool Tower thing.
Yeah.
If
well, that proves it's not flat, right? The elevation of the mountains in the distance means that it's not flat, because flat is a two-dimensional surface, and if there's an elevation change, then it's not flat. I mean, genius, Ranty. I mean, I don't know why he went to the Globe. He must have been paid.
There is someone calling himself Bumpy Earth. That's, yeah. No one denies mountains. It's the overall shape of everything that's the thing.
But the water level is a horizontal plane. Yeah.
Which follows...
Which you agree with. You agree with.
Again, on a local scale, yeah.
Yeah. Well, like I say, I don't ever measure anything that's not locally. I'm always there. Whenever I'm measuring anything, I definitely do that locally. And you're right. Every time I do that, the water level is horizontal. So brilliant. And I'm glad we can agree on things.
Back to that water level test. When you're going to set one horizontal at the first one, right?
Pardon?
You're going to set one horizontal at the first tube, as I understand.
Fill it up with water.
Is that right? Huh?
We put the water in the tube. Yep.
Yeah.
Yep.
And I heard something about you're going to have a surveyor setting a horizontal at the first tube.
Did you?
I picked that up somewhere. Yeah.
You think we need a surveyor to set a horizontal for
That's
where
just
the
what I heard in
water
the
level starts?
Something about hiring surveyors to make us. That's what I heard.
No. Mac Toon wanted us to price. He priced us up some surveyors. Right. I don't know who he'd had a word with. I mean, there was a guy there from Maine. Well, he was. McToon priced the job up. He said 3 days to make 2 marks on 2 posts.
Just to make clear,
the first one doesn't need a surveyor. You do that. You say this is where I want you to start. So the first one just gets started, and then you put the water level there, right? And then you check the water level at the other 2, right? So we don't need a surveyor. But McToon priced us £3,000 and said there was a day's calculations involved. I mean, I don't know how well McToon knows much about surveying. Does he know more than you?
I don't know. I can't talk for other people.
You don't know. How much would you charge somebody to put 2 marks on 2 posts? Well, you start with the first post, obviously, and you transpose that datum to 2 more, right? Using differential leveling. Like a half mile and then a mile. How much would you charge for that?
I have no idea what it is.
Pardon?
For me, as someone who's not professional and would need to hire the equipment, I don't know how much it costs.
So an auto level only costs about £100. I got my one for £100. Really cheap.
What he said, but
the water level's £100 as well, actually.
Yeah.
Yep.
But
way less than a P1000. Yeah.
As I started off with, this was just me asking, you're going to have a local horizontal at the first
it's the water. The water levels will show a shared straight line segment. You should get on the geometry bus with us. Man, it's beautiful. It's right line geometry.
This is a simple question, Dev. Are you going to have a horizontal at the first tube?
Am I going to have a horizontal? Well, yeah, the water level will establish that, right? You understand you do understand the law of communicating vessels, don't you?
Inside one little small 15 millimeter diameter tube, how are you going to set a horizontal?
It's the level of the water, isn't it? The water level establishes a horizontal plane, right? Well, that being one of the communicating vessels will be part of the entire system generated by all of the communicating vessels. They all become one.
You can't set a horizontal from one tube of water. You need equipment.
You just need a water level.
Not one tube.
Yeah, it is. It's like one connected body of water. Yeah, it needs to be.
Yeah,
it
but
does need to be one tube.
I'm talking about the first and one only tube. If you're going to have a local horizontal at that point, you can't use the other other tubes to do that.
Yeah, of course you can. That's what it does. It establishes a horizontal plane of reference. I mean, you can go both ways. I mean, that's the idea of it. It's to show you that they're all horizontal, all of them together, communicating horizontal. And we have a shared straight line in the middle, and that straight line extends out both ways, 400 meters each way from the middle. Like, you try drawing it. See if you can imagine how they would go together with the shared straight line segment in the middle.
No, yeah, I know. I understand the mechanism.
Have you tried modelling it yet? Have you got any of your guys to try modelling it?
I have.
You've modelled it.
Yeah.
That'd be cool. Let's have a look. Let's have a look at it. How do you imagine that the water level drops and humps? It does change, doesn't it? When you have two people, from one, it's a drop, right? You know, the guy on top of the ball, and then when you get two people, they have to be either side and with the hump in the middle. So there's nobody on there's nobody there. That's where the hump is.
Do you see my screen now?
Oh, wait a minute. Yep.
Yeah.
Okay.
So there are two different setups. One with red water and one with blue water.
You have seen the original test.
But just to make it sure, then this is an example,
brilliant.
Please.
Yeah.
Yeah.
That's it.
This is not
That's
reality
the one.
in any way, shape, or form. Are we clear on that?
That's the test, though. I'm saying that is the original test. Yeah. So you have seen it. Yeah, I like it. That's the easiest one for us to understand how it would work.
Can I just hear from you, from your own words? This is an example, please.
That's the test. That when we developed it, me and Spot On, the original test.
No misunderstanding.
That is it.
This is an example.
Yeah.
Yeah. Thank you. That's the only thing I want to hear, because this isn't reality, as I said so many times last time.
I'm saying that's the test. That's the original test.
So this is what you are expecting.
That's reality. That's what will happen. Yes, horizontal planes.
Except it wasn't. It isn't.
What do you mean it isn't?
This is what will happen.
What? Where's the water? What would
Same
happen
thing.
in the water levels?
Huh?
What is happening in the water levels?
Here you have the curvature of the Earth.
Yeah, but the water levels are still on the horizontal plane.
No.
Yeah, they are.
Yeah, the local horizontal. So this one here is the local horizontal for that one, but that doesn't match with the other ones. This
so
are
the blue ones higher than the red one in the center, or the red ones higher in the center? See, they don't. They're all the same in the center, so they are on the same horizontal plane then. All of the water levels.
In the center, because that's local. This is local.
What do you mean it's local to what? All the red ones are communicating, right?
Yeah.
So all of those are on a horizontal plane.
They're on the same level.
They go all the way across, right? They're twice the length of the blue ones.
Length doesn't matter.
Yeah, it does.
It's the distance between the further ones out the side.
Okay, so now from one end, are all of the water levels dropping? Is the question.
Now you're going back to semantics and wordplay.
It's not semantics. It's logic.
This is what I'm going to take by that one. Gone. So this is what I talked about when you have a camera out the other end here.
Right. So
if I have a camera here, this is what I'm talking about as an example.
Where's the water? Why is the water not at that top at that plane there? Like, why are all of the water levels on the same horizontal? Like, why?
This is the result of curvature.
How do you suppose that the red one is higher in the center?
Because that's how it will happen.
Well, that's not the law of communicating vessels.
When you have the
not horizontal, is it?
Wait a minute. I'm just going to scroll back here for a second. Just a second. Oh no. Yeah. I'm just going to scroll back in the chat here for a small while. You see the chat in my window now, yeah.
No, I'm looking at your thing.
Yeah, but I'm screen sharing the.
Right. Are you ever going to put any numbers on here?
Just 1 second. When you have this one,
Which one?
These
Are you
next to
back
each
in the
other.
chat again now? Am I having to close your window down?
I'm sharing that screen, aren't I?
You're sharing your screen, yeah.
Yeah. So this is local, 2 tubes next to each other.
Well,
And here we have
I'm
numbers.
seeing your cursor moving. I'm
Cool.
seeing
You
3
see the water
tubes.
behind it, okay.
No,
Yeah. If you have something to mark off on that tubes, lay them next to each other before the test or something, and you mark a line. So these are 10 something along here.
Are you moving your thing above them? Or
Can I please just
I'm
explain?
just trying to work out, you're trying to mark a line in the air above it, or am I not looking at the right picture?
You're seeing the 2 water tubes, aren't you?
I'm seeing the initial test with 3 guys.
Oh, that doesn't share through that. Okay, sorry. I put that. Yeah, sorry. I was having Discord on that screen, but it didn't show.
I know,
Sorry.
that's why I was saying you were waving your cursor around and there was nothing there.
Discord showed on my live stream because I'm sharing that screen. Whatever. Yeah, before you start, if you have just a mark on these and you fill it up to the same level all over in those tubes, this is what will happen on a sphere, on the globe.
The blue one there, though, looks higher in the center. It's not horizontal.
I'm going to remove that guy because he's just disturbing.
See, at that point there, see where you've got 3 lines crossing there. You've got 3 different planes, haven't
These
you?
yellow ones here, yeah.
Right. Well, are they horizontal?
That one is horizontal from the left one. That one is horizontal from the right one.
And what's the one in the middle?
Horizontal from the middle, yeah. Each and
So
every one has
there's 3 horizontals there in that connected with those water levels.
These yellow planes are the these are the horizontal planes from that.
They're intersecting horizontal planes. And what would you say if I said I had a logical proof from mathematics, geometry, that states that's impossible?
Well, I wouldn't say anything because I know nothing about it, but this is my prediction, and I think this will happen.
Oh, right, that's just a prediction. That's all right. So you're not trying to break mathematics.
Of course, you can't break mathematics.
Good.
That's impossible.
Well, then that's ridiculous. We can both safely say that.
Happen.
This is just your imagination of something that you imagine would happen.
Wait and see. Just wait and see. Results will tell. So, thing I was talking about the camera from here. When you have the camera on that same elevation as this one, those will drop away. If you raise that camera just a little bit, so those 2 outline each other, then top one will be taller. That's what I'm talking about earlier.
That's also, have you ever heard of the law of hydrostatic equilibrium?
And again, use all the words you like. This is reality.
Okay, I mean, that's not much of a defense, but okay. You just said that's your imagination, though. That's what you imagine.
Because the Earth is a globe.
Okay. Again.
From this horizontal plane, which now is just a blue line.
In there, but yeah, again.
Those will drop.
All right.
And if you have it at that level, the top one will be higher.
Hey, I don't mean to interrupt, but I'm not sure how long you guys wanted to go, and at some point you'll want to go into questions or something from other people. That'd be cool. Just whenever.
Yeah, good. Where did you want to get to at the end of this? You're scrutinising an old test. I mean, I like it. The fact that you've made a model and all of that.
But again,
there you go. That's reality. That's what will happen in reality, right?
The 3.1 millimeter, will that be from left end to right end?
I don't know. That's not the test, is it? That's the old original test. Now, do you want to talk about the numbers for that one?
I'm just asking which end was it from?
Because it's straight. It's a straight line test, and that would do, right? So let's say I'll make it easy for you because you say you're not that good at maths. So let's say the entire length from left side to right side, water level, red one, is 2 miles.
Yeah.
Right? Now,
excellent.
that makes it the middle red one, is 1 mile away.
Yeah.
Okay. And then, so that makes both of the blue ones individually 1 mile.
Yeah.
Right. Now, can we start with A on the right? Yeah.
Mm-hmm.
B in the middle and C on the right. A on the left, B in the middle, and C on the right. Right. When we're talking about these now, so we can talk about blue at A and blue at B. Right. That's one water level, and then you've got the blue at B to blue at C.
Yep.
Yeah. Okay. Now, let's go with the numbers right now. So you're the guy at A. Yeah. And now you're looking at the water level of the red tube, and you're looking at the guy at C. Now, the water level, I say, is horizontal all the way across. Is that what you say? Or do you say that the guy at C drops?
He drops.
Okay. Now, 2 miles, do you know the numbers for 2 miles?
Can I correct? Last time you asked me that, and I know I was wrong. I said a quarter of an inch or something. It's with 2-3 inches. I was wrong about that one.
Okay. Well, this is 2 miles.
Yeah. So that would be 32 inches or something.
Okay. So 32 inches below from the horizontal set at A. Right? Now, the guy at C, when he's looking at the guy at A, and he's holding the water level, the other guy is up, is he? Because he was down below it before, or is he also down? Like, what's the relationship of the guy at A to the guy at C?
That would be the same as the 2 sailboats we had in the chat here on live chat earlier.
Okay.
It's dropped from both of them, of course.
Okay, so that would be, you to imagine there's another 32 there.
No, it's not another.
Well, it's 32 inches below the horizontal set at C. Yeah?
Why should there be another? You don't add them up.
Okay, well, okay, but that's a drop, right? Now, so let's say the guy at A and the guy at B, right? So from A, the guy at B, what's the relationship to him on the blue level from A to B?
As long as it's curved with that drop, it would be... That is what a mistake the first time, and I know that now. Because it's a curve, it won't be just a half, it'll be something because the curve. I don't do math.
It's a quarter. It's a quarter function, but you already know a mile, don't you? It's the big one. That's the easy one, isn't it? 1 mile. So what's the relationship of the guy?
Yeah, then you have 8 inches, isn't it?
8.
Yeah,
so that's below, is it?
Still a drop.
Okay, right. So, and the same, I'm guessing, from C to B. That's also a drop.
8 inches.
Drop, right? But when you're looking at guy A and guy C together, when you're looking at the red bit, is that below the red bit? Also, is that below the horizontal set at A and the horizontal set at C? Is the red part below?
Happens. So when you talked about drop from
see, I guess what the problem I've got here is that you've got the guy at A and the guy at C establishing a horizontal that seems to be pointing up in the air. Doesn't seem to be horizontal for some reason.
Yeah, but I can also take every... If I do this...
Yeah.
And please don't stop working now. Oh, it's thinking. Have you seen? Oh.
Okay. I'm
OBS
going to
crashed
need to
5 minutes before we started.
take a quick break. I'm gagging for a brew, and I need to go
please.
for a toilet break. So I'll be back in a minute.
Cool. Well, I'm going to wait for that thinking. There it goes. Upside down. Oh, the fan is going.
I was just trying to remember what you said earlier. You said a measured vertical change from the horizontal is what exactly? I can't remember. Are you there, Tommy?
Yeah, excuse me. Yeah, what are you saying?
You said I mean, you're a surveyor. I just wanted to ask you. You said a measured vertical change from the horizontal is what?
I never said anything about that, so I can remember. Please enlighten me.
Oh, I thought you said it was something. If you measure a vertical change from the horizontal.
Vertical change from the horizontal. Yeah, then it's a drop.
You call it drop as a professional surveyor?
I am not a professional surveyor. I was working as a surveyor 20-some odd years ago, and I never went to school to learn it. So I was not a professional surveyor.
Oh, okay. So yeah, you don't really know.
I worked as one for 5 years. That's all. And that's over 20 years ago.
Would you be able to describe what a measured vertical change from the horizontal is? You just call it drop.
No, because as I just said to Bev several times, I don't do word games and semantics. So if I'm not using the correct words for you, you're going to have a ball at me. I'm not going to do that. Sorry.
Oh, so how do you communicate without words? That's kind of tricky.
Yeah, we do words, but again, if you don't like my words, you're going to have fun of me, so I'm not going to do that. That's word games. That's something different.
Oh, okay. I thought it was technical terms and definitions, but...
And I never claimed to be a professional surveyor. Sorry.
Like if I say something to you, like I'm driving down the road, does that make sense to you?
Sure.
That's not semantical or anything?
That's the way you say it. I drive down the road. Yeah, it's down. I know, but that's how you say it.
Yeah, like I'm describing something to you. I'm driving down the road.
But again, you're just making word games. I'm not into that, so sorry. I'm not gonna please you.
No, I'm just defining what I'm doing. I am.
Yeah, that's all you guys do. Definitions of wordplay. I'm not into that. I like reality.
Really?
Yeah.
Just communicating, right?
Yeah, but again, if you want to know what word I use for the horizontal drop of the, I'm not going to go that way. Sorry.
Yeah, that's fine. I was thinking, like, since you've done surveying, if I was surveying,
yeah, but again, 20 years ago, and I never claimed to be a professional surveyor. I never said that.
Yeah. I was just thinking, if I was measuring down these railroad tracks right here, and I measured a drop from that horizontal. What would I call that? Like if I measured a mile down.
Yeah, you can call everything exactly what you want. I don't care. I really don't care. Sorry.
Like, it looks, I could see a whole mile down there, and I'll measure all the way down using differential leveling.
Sure.
And I measure a 8-inch drop from that horizontal that I've established.
Use that.
You just call it
anything you like.
Anything.
Banana farts, I don't care. Call it what you want.
Yep.
It doesn't change reality.
Yeah, it doesn't change reality, does it?
That's why I don't do word games. Simple as that. Because you guys need to know exactly what other people think of words. And I don't care about
I was just thinking, like, if you did work at that and your boss said you measured an 8-inch change from the vertical, was it up or down? And you say, well, it's down.
Earlier, when I was there, it was a building site.
I can't even finish the sentence.
We weren't looking for curvature. We never measured for curvature. It was a building site. We never looked for curvature. That wasn't what we did.
Oh, you just measured horizontal distances?
No, we just measured to measure stuff. Objects, buildings, runways, establishing a grid or all that with GPS and stuff. We never looked for curvature. That wasn't what we did.
So you just measured from point A to point B, right? A horizontal distance from one building to maybe another building or something, right?
But again, this is a building site, a locally small building site, 13 square kilometers. You don't take curvature into consideration. Simple as that.
Yeah, I'm just talking about like you measure 100-foot horizontal distance between a building and another building. Is that too semantical, or is that okay?
That doesn't sound realistic at all, because we set out simple points, and the total station told us what the points were, and we measured that. Again, we wasn't looking for any curvature. That wasn't our job. There's a difference.
Yeah, I wasn't talking about curvature. I was talking about a horizontal distance. I wasn't talking about curvature.
Looking for curvature. That wasn't what we did.
I know. Why do you keep saying that? I'm not talking about that.
So why?
But see, like your total station, when you set up your total station, it basically says that it's right here at this location, right? It knows where it is. So when you move the total station, it knows where it is. So you have that position that you started at.
You don't set up.
Can you hear me?
You don't set up.
Can you hear me talking?
Huh?
Can you hear me talking?
Yeah.
Okay, cool. Yeah, I was almost finished with that sentence. Yeah. So you set up with the total station at position A, you move it to position B, and you're able to determine that your location based on those GPS coordinates, right, from the towers that triangulate your position.
Yeah, triangulation. Yeah.
So, I mean, it's like, it's not, I wouldn't technically call that a measurement though, right? Because you're just collecting data points. You put your equipment here, it says, I am here. You move it over there, and it says, I am here now. And you just calculate the difference.
From its point towards two other points, so you know the distance. Then it calculates the angles it have and into your precision. And again, as I said, nobody denies that surveying works. We don't need to go into the techniques. Surveying works.
Surveying works, yeah. Yeah, there's different modern surveying, with a total station, which is a data collector, and then there's actually measuring, like looking and looking at your measuring rod and determining, maybe distance or
of course, not
vertical
maybe.
height.
This is crucial.
Yes.
So what you're into? What you? As I said many times, we weren't looking for curvature. We were making buildings and runways.
I'm back.
Yeah. Right.
So
I
I
totally believe what you're saying, because I've never met a surveyor that measured curvature. I've talked to many surveyors.
Yeah, but
they'll laugh at you if you say, "Hey, you ever measured curvature?" They're like, "What? What do you mean?"
Yeah,
Well, there's measuring an elevation change that can be plotted as a curvature, right? I mean, that's
back to one-on-one. Who the other guy was, I don't know. You didn't see, but
okay.
Yeah.
I'll mute myself now so you're happy. Yeah.
While you were gone here, Bev, I rotated that one slightly, so this guy is standing straight up.
Actually, how would you propose to measure the curvature? I did hear that you surveying, when you were doing surveying, you didn't measure any curvature. But I mean, like, you did measure an elevation change, didn't you? Or did, like Cleary said, did you just calculate it?
That was a transfer, the height of one point to another by leveling.
Yeah, elevation changes, yeah.
Yeah.
Well, that's a change in the vertical distance from the horizontal, right?
But again, that is measuring curvature of the Earth.
You said you worked within 12 or 13 square kilometers, wasn't it?
Yeah.
Right, so is that 13 by 13? Or is that...
Of course it is. I was trying to say there's 2.1 kilometers between the runways, and those are about 5.3 kilometers long.
So it is 13 by 13 then. When you say 13 square kilometers, you mean 13 by 13? No.
Wouldn't that be 13 kilometers squared?
I'd say that's why I'm asking you. What do you mean by it? How big was the area that you were using?
Let's say outside runways and to the each end, about 3 times 5 minus a bit in the inside, because there's loading. It's a big H really. You can't take because there's a lot of area between.
What's like the longest distance along a runway then? for instance? Was
the longest run is some 5.3 kilometers or something.
Brilliant. So if you measure from one end of that differential leveling, and you measure a drop of, well, it doesn't matter, X, like, do you consider that an elevation change, or is that curvature? What happens?
We weren't measuring in the drop.
You were measuring an elevation change, were you? A change from the horizontal? Or was it perfectly flat?
Let's say we had point A at some point with 201 meters.
Yep.
And we just to transfer that over to another point somewhere else.
Yeah, like at the other end of the runway. The same runway from one end to the other. Was that perfectly flat, or was there an elevation change?
As long as you use an auto level, how can you tell?
You can tell what an elevation change is. Is that what you measured?
The thing is, if you can't measure in a curvature with an auto level.
Did you measure an elevation change with the auto level when you used it? Is that what you used them for? Right, now, over the distance of that...
That's terrain.
Right? Over the distance of that 5.3 kilometers, was it? If you measured... Did you ever measure a difference? Is there? I mean, like, you're the one that worked there. What sort of distance was it? What?
As I tried to say, Bev, please listen carefully. I'm going to say it once more, and that's it. We weren't looking for curvature.
I'm just asking you, what were you looking for?
We didn't look for anything. We set heights.
Yes, so you did elevation changes, right?
The first thing we did up there was measure an entire mountain that's going to be blown away. That's elevation change. That's not curvature. That's terrain.
Okay, brilliant. Yeah, I would agree with you. There's no curvature because you're using tools that establish horizontals and using shared straight line segments, parallel planes.
If you're leveling and you're going up a hill, that's elevation change. That's terrain, not curvature.
Yes.
There's difference.
Yeah.
Yeah.
So go on then. Okay. Right now, if that's how you measure an elevation change, which is a change in the vertical, if that's how you do it, it is how you do it. Right now, how would you propose, with all of your experience of surveying, to measure the curvature? What? Just give us the method.
Not with the auto leveling.
How would you propose to do it then?
Like the Struve geodetic arc. Triangulating over a large line. Long line, yeah.
Okay, so you couldn't do it locally, like with when Ruhif gave us those numbers of 3.1 millimeters. How would you propose to do? Ruhif's he used your model, didn't he?
Yeah, but the more local you get, the harder it is. That's the longer you go, the easier it is to find curvature. Of course, local is hard. It's
because of that not exponential. It's a quadratic function that you have within your formulas for your mathematical things, which is what gets us back to one of the beginning points, right? Curvature. How do you express or describe curvature? Have you thought about it yet? Because now you've been tasked with how do you measure it? But in order to be able to measure it, you need to know how to describe it. What is it that you are looking for? So first off, you have to point at what it is and then describe the thing that you are going to be looking for in order for you to be able to try and find it. So give us an idea on what this fabled curvature is. Go on. Give us your definition of it.
Not flat.
Not flat. Brilliant.
Yeah.
But all the tools that you use for surveying establish a horizontal plane.
You asked how I will find curvature. It's easy. Struve geodetic arc. They found it. Triangulation over a very, very, very large area.
Triangles with, like we established earlier, 180 degrees. Triangles. Yeah, I mean that doesn't. It doesn't mathematically work, or logically, it doesn't logically work. How you can use flat plane triangles as triangles are. Everybody knows what a triangle is. How you can use them and go, oh, look at that. I'm going to imagine there's a curve there. I'll write it down. Somebody will believe us. Don't worry.
But again, back to this model here. I'd straighten up that guy, so the guy A is now straight up. So he has a drop to guy C.
Yeah, but that's not how water levels off, is it? That's lower. I mean, that's ridiculous. Not only have you got intersecting horizontals, you've got the water would obviously piss out of the bottom one.
Yeah.
Because it's not level.
Sea guy. Why would the water run out on the sea guy there?
Because it's lower, it'd piss out. Look at it.
It's not lower, it's the same.
Of course it is. Look at it.
The distance
the
from
guy
the ground
on the left hand side is higher than the other two guys.
No, it isn't.
The water, due to the law of communicating vessels and the law of hydrostatic equilibrium, the water would piss out of the bottom because it would find its level.
Point here is the center of the Earth.
Where'd you get that from? Just imagined. It's all right.
What did we just talk about when I brought this up? This is an example. Are you now going for the reality again?
It's an example of what?
Seriously, Bev.
It's your model, dude.
Yeah, as I just said here.
It's an example. What is it an example of?
How it would work.
There you go. That's hydrostatic equilibrium, the law of communicating vessels, and reality. All there in that picture. Obvious. Everybody knows that's how it works.
Example. Please stick with your words. This is an example. Now I'm here. Still an example.
Yeah, that one's obviously ridiculous example. Like you don't think that could be anything, do you?
In our globe model,
you've obviously never held a water level, have you? You've never used a level, have you?
One,
Tommy.
Honest question. On our globe model, how is gravity supposed to work?
On your globe model.
How is gravity supposed to work?
Which globe model are you going with?
Just play with me in our globe model.
Which I don't know. You say our, which is like it's not. I don't have. I've got 1, 2, 3. I've got 3 models of globes in my room. So, right, which one of those do you want to talk about? Because neither of them are ours. They're all mine. These ones here. There's none that we jointly own. So please clarify. Which globe model are you imagining?
The model where the radius is 6,371 kilometers.
I've never seen that. That's ridiculous.
So, according to our globe model,
I've got a smaller one, smaller scale one.
What part of example did you understand?
Surely, if you had a model that big, I'd be able to see it, wouldn't I?
You're ecstatic about this one. This is example exactly the same. So now all of a sudden this isn't example anymore.
It's like
now
I'm not too keen on the word flat. Why have you wrote flat underneath it?
Flat is flat, isn't it? What's radius on a flat surface?
That's a horizontal plane, you mean? The water level establishing a horizontal plane. Because that's what you're talking about, right? It's just the water levels that we're talking about there, not the floor, the surface. It's a horizontal plane of water, right?
Yeah.
Right.
But the overall shape of the Earth isn't flat.
No, there are elevation changes. There are mountains and valleys. Well done. You're getting closer there. Well done.
Not local. Overall shape is a globe with a radius of 6,371 kilometers.
So you keep saying.
Yeah.
You don't seem to have much geometry or even knowledge of geometry to back that statement up.
So when this guy on the right there, guy C...
Or reality, obviously, because the water would piss out of that. It's obviously.
Nope.
Yeah. Yeah, there wouldn't be any water left in the guy on the left-hand side. Because it would all piss out to be the level of the guy at the right. That's how water level works. It establishes a horizontal plane of reference.
That's how gravity works, Bev.
Gravity? Well, that acts perpendicularly, right?
Yeah.
Mm-hmm. Oh, well, that's perpendicular to vertical is horizontal.
No, perpendicular to horizontal, not perpendicular to vertical. Perpendicular to horizontal.
No, perpendicular to vertical is horizontal.
Yeah, gravity works perpendicular to horizontal.
Yes, like I say, perpendicular, straight lines. Gravity acts to a straight line, and all perpendiculars to the plane will be parallel, won't they?
Now you're doing word games again.
No, this is mathematical proofs. They're called propositions, right? But what they are proofs within geometry, actual proofs.
Computer tech, because it's slow as F now. Come on.
Did you hear that, Tommy?
Yeah, but
proofs, again... proofs. When you say, give me proof, well, this is where proofs come from. Mathematics, geometry.
Can this machine please stop thinking now? It will be great. Yeah, there. Let's do all Australia on it. Here, still works. No problems.
It doesn't.
That's Australia for you.
Ridiculous, dude.
Yeah, of course it is.
I'm surprised you went to that. I mean, that's even worse than before.
That is the globe model with gravity.
Fantastic.
Yep.
Cool story, bro.
So
turning your model upside down proves what?
Again, it doesn't prove it. It's an example.
Okay.
As I said at the first step, please, this is an example.
But that's not how water levels work in reality.
That's what you're going to find out. When you do that test, this is exactly what you're going to find out.
The water doesn't drop. That water dropping like that is what happens when it's a river. There's a different pressure change. The hydrostatic equilibrium of the vertical column, right, would be different, causing a difference in pressure. That causes flow of water. Water would move to establish its own level. You should really look into the law of communicating vessels and the law of hydrostatic equilibrium.
Yeah, but again, when you do this, reality will smack up your side of your head.
Brilliant. Well, I'll be the first person to record it, won't I?
Hopefully, yeah. With that P1000.
You could do it yourself. No. It's the water levels. 100 pounds worth of water levels. You could do it yourself. Or you get somebody else to do it, and then you could go with your camera, couldn't you? You could look at it.
You are doing it, aren't you? Sometime, yeah. After this...
Dude, this is a personal thing, right? It's to prove right line geometry, the practical geometry of reality.
And that's exactly what I'm saying. When you have done this test, when you find this result, you said you're going to connect someone else's, then the drop is going to be even more. What are you going to say then?
Well, I'll say what I do say now. I'd be like, if I find that the water level drops at a measurable rate, I will say, well, fuck me. That's brilliant. But I can't see how that's going to happen, to be honest with you, because water level is a horizontal plane. Everybody knows that. Well, I'd say everybody, apart from a few delusional people that are over enthusiastic about a model that they know really nothing about geometrically.
So I'm not going to set money on it, but my bet is that you'll find that the water drops.
Mm-hmm. There's no drop to a horizontal plane.
No, it isn't. Of course it isn't. As I just said, we agree on that one.
And you also agreed that we could indefinitely extend a horizontal plane.
Yeah, as this yellow, as I just marked blue here, that horizontal plane doesn't stop to be a horizontal plane for that guy A. That's his horizontal plane. No problems.
You've got 3 interconnecting horizontal planes there, right?
Yeah, they have to be because they're standing a distance apart.
They have to be. Well, that sounds
So
ridiculous. Is it your model that tells you it has to be? Or
take away those 2.
do you have some sort of founding in reality?
That's his horizontal plane. Founding in reality,
then you have to tilt it the other way, don't you? In order to get the other guy with a horizontal plane. I mean, it's like it's so obvious.
You asked if I
they're
had
below. There's a measurable drop.
You asked if I had something in reality, and I say my wind turbines, because my wind turbines are down here somewhere at a distance. So yeah.
Optical drop, right? You've not measured that, have you?
One more question.
Do you think a measured elevation is a drop?
No, again, that
do
could be
you
terrain.
think a measured even elevation or even altitude is a drop?
Measured even elevation?
Yeah.
Isn't that horizontal plane? Again,
well, I would say so, but you don't, apparently.
Again, you're going to word games.
No, it's not word games. Look, just because you've got screwed up in your own head, your cog dis has got you. An even elevation, you just said, is a horizontal plane.
Isn't it? Again, word games. And if I answer,
it's not word games. Even elevation would be the surface of water, wouldn't it?
No.
You don't think the surface... Oh, wow. Yeah. Come on, Tommy.
Even elevation, because elevation goes around the curvature.
Okay, right. So how can that be a horizontal plane?
It isn't.
Okay, but you just said it was before. You're getting messed up with your own model, Tommy.
For this guy A here,
do you keep getting mixed up between reality and a model?
No. Again, I get mixed up in your word games. That's what I don't do that.
Okay, so...
Because you're an expert at word games, and that's all. So, for this guy here, guy A, this is his local horizontal. Down here is his local horizontal. Over here, it isn't. Play all your word games you want, Bev. I'm no expert in word games as you are.
So...
Reality will kick your ass when you do this.
So,
sorry.
okay, but one guy's horizontal, when that first guy's horizontal, right, intersects with... that other guy's vertical, right? So there's a vertical intersecting a horizontal there, right?
At this point, yeah.
Are they...
Right,
oh, they don't look perpendicular, do they?
Of course they're not.
What, a vertical and a horizontal that aren't perpendicular?
Because that vertical is another place.
What? No. Vertical and horizontal are definitely perpendiculars. That's one of the mathematical things. In reality as well. I mean, we base all of our frames of reference on vertical and horizontal being perpendicular. But you've just said there that a vertical and a horizontal aren't perpendicular. I mean, they are in reality. Everybody knows that they are.
Locally, yeah.
Oh.
Now they are, because this is his guy's local horizontal. Now they are vertical and perpendicular.
No. That's not how geometry... You've obviously geometrically illiterate.
That's how reality works.
You should go and brush up a bit on geometry.
This is how reality...
No,
you talked about...
That's
you
not
talked
how...
about here.
No, we use... In reality, we use Euclidean principles for surveying. And those principles are based around right lines. They are the two frames of reference that we use, everybody uses in reality. Vertical and horizontal.
Yeah.
Vertical and horizontal are perpendicular.
Don't deny that, Bev.
Brilliant.
We never deny that. That's locally.
You did just earlier say that a vertical and a horizontal weren't.
Yeah, because that's not this guy's horizontal. That's this guy's horizontal here.
It's just vertical and horizontal, dude. Just vertical and horizontal are perpendicular. Always.
Locally, yeah.
Always.
Locally.
Yeah. Do you have can you hold the concept where a vertical and a horizontal could be parallel? Could you imagine that?
Before you switch point, I'm going to end this. This guy's local horizontal is perpendicular to vertical. We don't deny that. Move away from that guy over here. This guy's local horizontal is vertical to his perpendicular, but not to the other guy's horizontal. Move further away. That guy's local horizontal is vertical to perpendicular, vertical to vertical, sorry. But it's not to that other guy's horizontal because curvature.
No, horizontal and vertical are perpendicular, right?
Locally,
there's no imagined model that could get me to think that a vertical and a horizontal could be parallel. Or even a horizontal and a horizontal being perpendicular. I mean, can you imagine the concepts you'd have to go and put into your mind to be able to think that? It's crazy. It's crazy. One person's horizontal could be another person's vertical.
Bev,
imagine it.
I misspoke in there. I'm sorry. English is still not my first language. And this is technical English. Sorry if I misspoke. Should we talk this in Norwegian? Should we switch to Norwegian?
I don't know. I'm still trying to get over the fact that it's people could believe that verticals and horizontals weren't perpendicular.
Vi kan godt fortsette på norsk. Altså, hvis jeg fortsetter å prate her, og du ikke skjønner bæret av hva jeg snakker om, hvordan skal vi ta det da?
Sweet.
Yeah. So, if I misspoke, sorry. This guy's horizontal is not the other guy's horizontal. So, that guy's horizontal is perpendicular to vertical.
Yeah, I see. I can't ever think that horizontals might intersect. So I can't even imagine what you're doing here. All I can imagine is that you're being led by a model, and you supposedly meant to have been a surveyor.
This is how horizontal and vertical works on a globe.
Oh, on a model. Yeah, I'd see. That's where I'm having a problem. I only live in reality, so I only deal with reality stuff.
Reality is a globe. As I said, you'll find this out. I'm going to take that back one. When you do your water level test, reality will smack upside your head, kick your ass. Seriously.
Really?
But we're going to end now. It's late here.
Okay, sweet. Well, thanks for popping around. You want to take some questions, or should I do that? We'll do the super chats.
We're not going to open.
Have you got any super chats, Tommy?
No, I'm not monetized.
Oh, right.
I don't do money on this.
Oh, right. Is that you just after the truth?
Yeah, sure.
Are you wanting to join the YouTuber crew? Content creators.
Say again, please. What?
Are you wanting to join the YouTube content creators?
I am a content creator, yeah.
Yeah, I know. Are you wanting to join the big guys, though? I mean, are you trying to get in there? The big boys. Well,
I haven't seen my channel. I'm all by myself. Yeah. I do everything by myself. Yeah. It's me. Ben.
Yeah. Everybody does it on their own, don't they? I mean, it's your YouTube channel. I mean, so you don't have any backing of anyone, then. But I mean, that's what I'm saying. Are you not wanting to get in with them? Like a debunker, is that what you class yourself as?
Yes.
Okay.
Thing is about
when you come round here, right? What is it that you imagine you're trying to debunk?
Started with D. Marble, who told me the Earth is flat. So I went from there.
It's not flat.
And
I'll tell you, it's not. I can prove it's not by surveying. Yeah, you've done surveying. You know there's an elevation change. It's like, there's mountains and valleys. Definitely not flat. That's a ridiculous statement to say it's flat.
Let's just repeat this one more time, Bev. I never looked for curvature. We set up buildings and runways and never looked for curvature.
Because there's no curvature to a horizontal plane. There's only elevation changes to parallel horizontal planes. That's all you'll ever find, right? All you'll ever find.
Depends on the size.
Just coming from reality. right? So when you come here and you're trying to debunk something, what do you imagine you're trying to debunk?
People who think the Earth is anything but a globe, like some people who think the Earth is flat. Yeah.
We're just saying how surveying is performed in reality. That's all we do here.
We know the surveying works.
We've never said it's flat, dude. We say it's not flat. Observably not flat. I can prove it. I can prove it with surveying techniques to show you an elevation change. Right, so so what is it again that you are trying to debunk when you come here?
Again, those turbines I have in my photos, the water goes down somehow. So
you're trying to debunk water being a horizontal plane of reference.
Locally, it is not.
So you're not trying to debunk water being a horizontal plane of reference then? So what is it again Tommy, what is it you are trying to debunk?
You want me to get stuck in your wordplay?
No, I'm not. I want you to speak the truth. Tell me what it is you are trying to debunk when you come here.
To come here in your chat on this here now to talk to you. That's what I ever talk. That's what we're here for.
Okay, so you're not trying to debunk anything here then. You just come for a chat.
Just showing you how stuff works, and you show me how stuff works. So yeah, this is a discussion, not a debunking something.
Sweet, good. How do you think you've done today?
We had a good talk, didn't we?
Sweet, yeah. I think we have.
Yeah.
And are you gonna can you devise a method, or is that your method? Is just looking at things with cameras? Is that where we've got to look forward to?
A water test is an excellent way to start, of course. Yeah, as long as
are you going to do one?
If I had the means to do it, of course.
£100. That's all it takes, and then you get together with somebody else.
Yeah, but I would suggest even larger scale.
Well, I mean, who knows? It's only small scale testing at the minute. I mean, you need to do your testing. You need to do your own testing because there'll be problems. You don't want to end up with the slice bar cane leaky thing, or even not even checking the elevation. That's a great one that we heard the other day.
We are small.
Pardon?
Earth is big. We are small. So the smaller scale test you go, the harder it is to find temperature.
You're not a sizist, are you? You're not having a go at me because I'm small.
You can't do small scale tests to find something big.
What? Yeah, you can. Straight lines. There's no scale to a straight line. If you can extend a straight line indefinitely and extend a horizontal plane indefinitely, then there's no scale to it, right? Where's the scale to a straight line?
If you are going to figure out
the difference curving.
If you're going to figure out the difference between a curve and a straight line, where the curve is minute.
No, I already know the difference between a curve and a straight line.
Yeah, but when that difference isn't that big.
It's geometry.
You have
3.1 millimeters over 200 meters.
Yeah.
Well, that's measurable, isn't it?
That's you. No, it was you who measured.
Oh yeah, it's measurable. That's what Jesse Kozlowski said.
This time it was you who mentioned slide first, so I'm going to repeat him for once.
Slice bending water level experiment.
His test is 1 mile. That's a bit better. The longer, the better.
Yeah, 16 100 meter water levels. Yeah, we only need 400 because Ruhif gave us the numbers.
Yeah. But you asked me if I want to do it, and I say of course I would, but I would do it larger scale, as large as possible.
Yeah, well, if you get 400 meters, I get 400 meters. Spot On gets 400 meters. DP can get 400 meters. Boom, 1600 meters. Let's have a party. Let's go for a weekend. Do it by the side of a pub at the canal. That'd be great.
If I should do this, I think I would try to pass 1 kilometer at least. Yeah. But again, I'm probably not going to do it. If I could, I would.
Shared straight line segments, right? That's the key. Geometry is the key.
And now you go back to our games.
Should jump on the geometry bus with us.
Nope.
No.
But again,
how do you find your proofs then? Are you looking at things? I remember. Ranty approach.
That's reality. That's what I'm going to say. So, should we end this here? It's been 3.5 hours now.
Yeah, that's fine. Do you want to take some questions from the guys who've been sat here waiting? Do you like the way they've all sat there?
Yeah, thanks to everyone in the room. I really appreciate this one. I had one guy where you were away. That's okay. This was not a 5-on-1. I really, really appreciate this. Thank you.
Yeah,
You're welcome.
We can do that with all of us here. This is what we do.
If this had been 48 hours ago, this would be great. So, Cleary, since you're the owner now, I said thank you.
There you
this
go.
Was fun.
Inviting you in.
This is how it's supposed to be.
Yeah, he came in because I went to the toilet, right? It was dead air.
But that was one guy. That's okay. He was one guy.
Mm-hmm.
I didn't have to bother myself to sleep here. So, thank you for the talk. I appreciate this.
No problem. Thanks for popping in.
Yeah.
Tell your friends.
Is Flatsoid in here, or is it? He was here earlier?
Yeah, it doesn't look like he's in here now. I can have a word with him if you want to. Did you say you wanted to have a debate with him as well? That wasn't a debate, was it? It was just a chat. Would you wanted to have a chat with Flatsoid? I don't know whether your mic's just dropped or not. Looks like Tommy's finished, guys. If you want to come and ask us a few questions or anything. Or is that me? Is my mic gone? Somebody answer. Come on. Do I have to drop out and come back again? Oh. Oh. Let's see whether the audio is here. Yeah, my mic's on. Looks like I've dropped from Discord. Let's see if we can sort this out. Yeah, looks like Discord's dropped. Is that going on? Are we still on YouTube? I should have checked. Oh, 3 spaces off. Hello. Am I still on here? Discord's gone. Am I still on the audio for... Can you guys still hear me on the... I don't know what's going on with Discord here. Reset Discord, try that. No, doesn't seem to be working. Well, I guess I'm going to have to talk to you guys because I don't know what Discord's gone down. Can't have any questions or anything. Nice one, Shills. Yeah, I don't know. Reality bites. Yeah, Discord is not letting me connect. down here. Yeah. Yeah, it's not working. How do you think we handled that with the one-on-one? It was a bit demanding, wasn't he? I don't know what he meant to talk about. I'm no good at talking on my own. I'm waiting for Discord to catch up, and it's not, obviously. Let me see if I can start trying to get in a different server. No, for some reason Discord's not letting me join. Let's see whether I can get in on the phone. Hello? Hello? See whether I can get in on the phone. Oh, gonna have to turn that off. You, hello. Am I on here? Hello. See, that's not even working either. Hello? No, that's not working either. Don't know what's going on here. It's just not letting me on Discord at all, either account. I can't hear anything. Wow. Right, well then, I guess. Not wanting to do this and keep you guys going here on the YouTube. I'll have to cut this short. It'd be good to chat with all of the rest of them. Right, well then, I guess. I can't. I'll give it one more try. I'm going to have to shut it down and restart my PC or something. Yeah, I'm going to have to refresh the whole PC. So I'll shut this down and come back. I might come back live if it starts back up again.